1926.1101, Asbestos. 1926.1101, Scope and Application. This section regulates asbestos exposure in all work as defined in 29 CFR 1910.12, b, including but not limited to the following: 1926.1101, A1 through 1926.1101, A8, demolition or salvage of structures where asbestos is present, removal or encapsulation of materials containing asbestos, construction, alteration, repair, maintenance, or renovation of structures, substrates, or portions thereof that contain asbestos, installation of products containing asbestos, asbestos spill/emergency cleanup, and transportation, disposal, storage, containment of and housekeeping activities involving asbestos or products containing asbestos on the site or location at which construction activities are performed. Coverage under this standard shall be based on the nature of the work operation involving asbestos exposure. This section does not apply to asbestos containing asphalt roof coatings, cements, and mastics. 1926.1101, b, definitions. Aggressive method means removal or disturbance of building material by sanding, abrading, grinding, or other method that breaks, crumbles, or disintegrates intact ACM. Amended water means water to which surfactant, wetting agent, has been added to increase the ability of the liquid to penetrate ACM. Asbestos includes chrysotile, amosite, crocitolite, tremolite asbestos, anthophyllite asbestos, actinolite asbestos, and any of these minerals that has been chemically treated and/or altered. For purposes of this standard, asbestos includes PACM, as defined below. Asbestos-containing material, ACM, means any material containing more than 1% asbestos. Assistant Secretary means the Assistant Secretary of Labor for Occupational Safety and Health, U.S. Department of Labor, or designee. Authorized person means any person authorized by the employer and required by work duties to be present in regulated areas. Building/facility owner is the legal entity, including a lessee, which exercises control over management and record-keeping functions relating to a building and/or facility in which activities covered by this standard take place. Certified Industrial Hygienist, CIH, means one certified in the practice of industrial hygiene by the American Board of Industrial Hygiene. Class 1 asbestos work means activities involving the removal of TSI and surfacing ACM and PACM. Class 2 asbestos work means activities involving the removal of ACM which is not thermal system insulation or surfacing material. This includes, but is not limited to, the removal of asbestos-containing wallboard, floor tile and sheeting, roofing and siding shingles, and construction mastics. Class 3 asbestos work means repair and maintenance operations where ACM, including TSI and surfacing ACM and PACM, is likely to be disturbed. Class 4 asbestos work means maintenance and custodial activities during which employees contact but do not disturb ACM or PACM and activities to clean up dust, waste and debris resulting from Class 1, 2, and 3 activities. Clean room means an uncontaminated room having facilities for the storage of employees' street clothing and uncontaminated materials and equipment. Closely resemble means that the major workplace conditions which have contributed to the levels of historic asbestos exposure are no more protective than conditions of the current workplace. Competent person means, in addition to the definition in 29 CFR 1926.32, f, one who is capable of identifying existing asbestos hazards in the workplace and selecting the appropriate control strategy for asbestos exposure, who has the authority to take prompt corrective measures to eliminate them, as specified in 29 CFR 1926.32, f. In addition, for Class 1 and Class 2 work who is specially trained in a training course which meets the criteria of EPA's Model Accreditation Plan, 40 CFR Part 763, for supervisor, or its equivalent, and, for Class 3 and Class 4 work, who is trained in a manner consistent with EPA requirements for training of local education agency maintenance and custodial staff as set forth at 40 CFR 763.92, a. 2. Critical barrier means one or more layers of plastic sealed over all openings into a work area or any other similarly placed physical barrier sufficient to prevent airborne asbestos in a work area from migrating to an adjacent area. Decontamination area means an enclosed area adjacent and connected to the regulated area and consisting of an equipment room, shower area, and clean room, which is used for the decontamination of workers, materials, and equipment that are contaminated with asbestos. Demolition means the wrecking or taking out of any load-supporting structural member and any related raising, removing, or stripping of asbestos products. Director means the Director, National Institute for Occupational Safety and Health, U.S. Department of Health and Human Services, or designee. Disturbance means activities that disrupt the matrix of ACM or PACM, crumble or pulverize ACM or PACM, or generate visible debris from ACM or PACM. In no event shall the amount of ACM or PACM so disturbed exceed that which can be contained in one glove bag or waste bag, which shall not exceed 60 inches in length and width. Employee exposure means that exposure to airborne asbestos that would occur if the employee were not using respiratory protective equipment. Equipment room, change room, means a contaminated room located within the decontamination area that is supplied with impermeable bags or containers for the disposal of contaminated protective clothing and equipment. Fiber means a particulate form of asbestos, 5 micrometers or longer, with a length-to-diameter ratio of at least 3:1. Glove bag means not more than a 60 by 60 inch impervious plastic bag-like enclosure affixed around an asbestos-containing material, with glove-like appendages through which material and tools may be handled. High-efficiency particulate air (HEPA) filter means a filter capable of trapping and retaining at least 99.97% of all monodispersed particles of 0.3 micrometers in diameter. Homogeneous area means an area of surfacing material or thermal system insulation that is uniform in color and texture. Industrial hygienist means a professional qualified by education, training, and experience to anticipate, recognize, evaluate, and develop controls for occupational health hazards. Intact means that the ACM has not crumbled, been pulverized, or otherwise deteriorated so that the asbestos is no longer likely to be bound with its matrix. Modification for purposes of paragraph G6(2) means a changed or altered procedure, material, or component of a control system, which replaces a procedure, material, or component of a required system. Omitting a procedure or component, or reducing or diminishing the stringency or strength of a material or component of the control system is not a modification for purposes of paragraph G6 of this section. Negative initial exposure assessment means a demonstration by the employer, which complies with the criteria in paragraph F2(3) of this section, that employee exposure during an operation is expected to be consistently below the PL's. PACM means presumed asbestos containing material. Presumed asbestos containing material means thermal system insulation and surfacing material found in buildings constructed no later than 1980. The designation of a material as PACM may be rebutted pursuant to paragraph K5 of this section. Project designer means a person who has successfully completed the training requirements for an abatement project designer established by 40 U.S.C. 763.90 G. Regulated area means an area established by the employer to demarcate areas where Class 1, 2, and 3 asbestos work is conducted, and any adjoining area where debris and waste from such asbestos work accumulate, and a work area within which airborne concentrations of asbestos exceed or there is a reasonable possibility they may exceed the permissible exposure limit. Requirements for regulated areas are set out in paragraph E of this section. Removal means all operations where ACM and/or PACM is taken out or stripped from structures or substrates, and includes demolition operations. Renovation means the modifying of any existing structure or portion thereof. Repair means overhauling, rebuilding, reconstructing, or reconditioning of structures or substrates, including encapsulation or other repair of ACM or PACM attached to structures or substrates. Surfacing material means material that is sprayed, troweled on, or otherwise applied to surfaces, such as acoustical plaster on ceilings and fireproofing materials on structural members, or other materials on surfaces for acoustical, fireproofing, and other purposes. Surfacing ACM means surfacing material which contains more than 1% asbestos. Thermal system insulation, TSI, means ACM applied to pipes, fittings, boilers, bridging, tanks, ducts, or other structural components to prevent heat loss or gain. Thermal system insulation ACM is thermal system insulation which contains more than 1% asbestos. 1926.1101 C. Permissible exposure limits, PLS. 1926.1101 C1. Time-weighted average limit, TWA. The employer shall ensure that no employee is exposed to an airborne concentration of asbestos in excess of 0.1 fiber per cubic centimeter of air as an 8-hour time-weighted average, TWA, as determined by the method prescribed in Appendix A to this section, or by an equivalent method. 1926.1101 C2. Excursion limit. The employer shall ensure that no employee is exposed to an airborne concentration of asbestos in excess of 1.0 fiber per cubic centimeter of air, 1F/cc, as averaged over a sampling period of 30 minutes, as determined by the method prescribed in Appendix A to this section, or by an equivalent method. 1926.1101 D. Multi-employer worksites. 1926.1101 D1. On multi-employer worksites, an employer performing work requiring the establishment of a regulated area shall inform other employers on the site of the nature of the employer's work with asbestos and/or PCM, of the existence of and requirements pertaining to regulated areas, and the measures taken to ensure that employees of such other employers are not exposed to asbestos. 1926.1101 D2. Asbestos hazards at a multi-employer worksite shall be abetted by the contractor who created or controls the source of asbestos contamination. For example, if there is a significant breach of an enclosure containing Class 1 work, the employer responsible for erecting the enclosure shall repair the breach immediately. 1926.1101 D3. In addition, all employers of employees exposed to asbestos hazards shall comply with applicable protective provisions to protect their employees. For example, if employees working immediately adjacent to a Class 1 asbestos job are exposed to asbestos due to the inadequate containment of such job, their employer shall either remove the employees from the area until the enclosure breach is repaired, or perform an initial exposure assessment pursuant to F of this section. 1926.1101 D4. All employers of employees working adjacent to regulated areas established by another employer on a multi-employer worksite shall take steps on a daily basis to ascertain the integrity of the enclosure and/or the effectiveness of the control method relied on by the primary asbestos contractor to assure that asbestos fibers do not migrate to such adjacent areas. 1926.1101 D5. All general contractors on a construction project which includes work covered by this standard shall be deemed to exercise general supervisory authority over the work covered by this standard, even though the general contractor is not qualified to serve as the asbestos competent person as defined by paragraph B of this section. As supervisor of the entire project, the general contractor shall ascertain whether the asbestos contractor is in compliance with this standard, and shall require such contractor to come into compliance with this standard when necessary. 1926.1101 E1. All Class 1, 2 and 3 asbestos work shall be conducted within regulated areas. All other operations covered by this standard shall be conducted within a regulated area where airborne concentrations of asbestos exceed, or there is a reasonable possibility they may exceed a PL. Regulated areas shall comply with the requirements of paragraphs 2, 3, 4, and 5 of this section. 1926.1101 E2. Demarcation. The regulated area shall be demarcated in any manner that minimizes the number of persons within the area and protects persons outside the area from exposure to airborne asbestos. Where critical barriers or negative pressure enclosures are used, they may demarcate the regulated area. Signs shall be provided and displayed pursuant to the requirements of paragraph K7 of this section. 1926.1101 E3. Access. Access to regulated areas shall be limited to authorized persons and to persons authorized by the Act or regulations issued pursuant thereto. 1926.1101 E4. Respirators. All persons entering a regulated area where employees are required pursuant to paragraph H1 of this section to wear respirators shall be supplied with a respirator selected in accordance with paragraph H3 of this section. 1926.1101(e)(5) Prohibited activities. The employer shall ensure that employees do not eat, drink, smoke, chew tobacco or gum, or apply cosmetics in the regulated area. 1926.1101(e)(6) Competent persons. The employer shall ensure that all asbestos work performed within regulated areas is supervised by a competent person, as defined in paragraph B of this section. The duties of the competent person are set out in paragraph O of this section. 1926.1101(f) Exposure assessments and monitoring. 1926.1101(f)(1) General monitoring criteria. 1926.1101(f)(1) Each employer who has a workplace or work operation where exposure monitoring is required under this section shall perform monitoring to determine accurately the airborne concentrations of asbestos to which employees may be exposed. 1926.1101(f)(1)(2) Determinations of employee exposure shall be made from breathing zone air samples that are representative of the 8-hour TWA and 30-minute short-term exposures of each employee. 1926.1101(f)(1)(3) Representative 8-hour TWA employee exposure shall be determined on the basis of one or more samples representing full shift exposure for employees in each work area. Representative 30-minute short-term employee exposures shall be determined on the basis of one or more samples representing 30-minute exposures associated with operations that are most likely to produce exposures above the excursion limit for employees in each work area. 1926.1101(f)(2) Initial exposure assessment. 1926.1101(f)(2) Each employer who has a workplace or work operation covered by this standard shall ensure that a competent person conducts an exposure assessment immediately before or at the initiation of the operation to ascertain expected exposures during that operation or workplace. The assessment must be completed in time to comply with requirements which are triggered by exposure data or the lack of a negative exposure assessment, and to provide information necessary to assure that all control systems planned are appropriate for that operation and will work properly. 1926.1101(f)(2) Basis of initial exposure assessment. Unless a negative exposure assessment has been made pursuant to paragraph F(2)(3) of this section, the initial exposure assessment shall, if feasible, be based on monitoring conducted pursuant to paragraph F(1)(3) of this section. The assessment shall take into consideration both the monitoring results and all observations, information or calculations which indicate employee exposure to asbestos, including any previous monitoring conducted in the workplace, or of the operations of the employer which indicate the levels of airborne asbestos likely to be encountered on the job. For Class 1 asbestos work, until the employer conducts exposure monitoring and documents that employees on that job will not be exposed in excess of the PLs, or otherwise makes a negative exposure assessment pursuant to paragraph F(2)(3) of this section, the employer shall presume that employees are exposed in excess of the TWA and excursion limit. 1926.1101(f)(2)(3) Negative exposure assessment. For any one specific asbestos job which will be performed by employees who have been trained in compliance with the standard, the employer may demonstrate that employee exposures will be below the PLs by data which conform to the following criteria. 1926.1101(f)(2)(3) Objective data demonstrating that the product or material containing asbestos minerals or the activity involving such product or material cannot release airborne fibers in concentrations exceeding the TWA and excursion limit under those work conditions having the greatest potential for releasing asbestos, or 1926.1101(f)(2)(3)(b) where the employer has monitored prior asbestos jobs for the PL and the excursion limit within 12 months of the current or projected job. The monitoring and analysis were performed in compliance with the asbestos standard in effect, and the data were obtained during work operations conducted under workplace conditions closely resembling the processes, type of material, control methods, work practices, and environmental conditions used and prevailing in the employer's current operations. The operations were conducted by employees whose training and experience are no more extensive than that of employees performing the current job. And these data show that under the conditions prevailing and which will prevail in the current workplace, there is a high degree of certainty that employee exposures will not exceed the TWA and excursion limit, or 1926.1101(f) 2, 3, c. The results of initial exposure monitoring of the current job made from breathing zone air samples that are representative of the 8-hour TWA and 30-minute short-term exposures of each employee covering operations which are most likely during the performance of the entire asbestos job to result in exposures over the PLs. 1926.1101, F. 3. Periodic monitoring. 1926.1101, F. 3. I. Class 1 and 2 operations. The employer shall conduct daily monitoring that is representative of the exposure of each employee who is assigned to work within a regulated area who is performing Class 1 or 2 work, unless the employer pursuant to F. 2, 3 of this section has made a negative exposure assessment for the entire operation. 1926.1101, F. 3, 2, all operations under the standard other than Class 1 and 2 operations. The employer shall conduct periodic monitoring of all work where exposures are expected to exceed a PL, at intervals sufficient to document the validity of the exposure prediction. 1926.1101, F. 3, 3, exception. When all employees required to be monitored daily are equipped with supplied air respirators operated in the pressure demand mode, or other positive pressure mode, the employer may dispense with the daily monitoring required by this paragraph. However, employees performing Class 1 work using a control method which is not listed in paragraph G, 4, I, 2, or 3 of this section or using a modification of a listed control method, shall continue to be monitored daily even if they are equipped with supplied air respirators. 1926.1101, F. 4. Termination of monitoring. 1926.1101, F. 4, I. If the periodic monitoring required by paragraph F. 3 of this section reveals that employee exposures, as indicated by statistically reliable measurements, are below the permissible exposure limit and excursion limit, the employer may discontinue monitoring for those employees whose exposures are represented by such monitoring. 1926.1101, F. 4, 2, additional monitoring. Notwithstanding the provisions of paragraph F. 2 and 3 and F. 4 of this section, the employer shall institute the exposure monitoring required under paragraph F. 3 of this section whenever there has been a change in process, control equipment, personnel, or work practices that may result in new or additional exposures above the permissible exposure limit and/or excursion limit, or when the employer has any reason to suspect that a change may result in new or additional exposures above the permissible exposure limit and/or excursion limit. Such additional monitoring is required regardless of whether a negative exposure assessment was previously produced for a specific job. 1926.1101, F. 5. Employee notification of monitoring results. The employer must, as soon as possible but no later than 5 working days after the receipt of the results of any monitoring performed under this section, notify each affected employee of these results either individually in writing or by posting the results in an appropriate location that is accessible to employees. 1926.1101, F. 6. Observation of monitoring. 1926.1101, F. 6, I. The employer shall provide affected employees and their designated representatives an opportunity to observe any monitoring of employee exposure to asbestos conducted in accordance with this section. 1926.1101, F. 6, 2. When observation of the monitoring of employee exposure to asbestos requires entry into an area where the use of protective clothing or equipment is required, the observer shall be provided with and be required to use such clothing and equipment and shall comply with all other applicable safety and health procedures. 1926.1101, G. Methods of compliance. 1926.1101, G1. Engineering controls and work practices for all operations covered by this section. The employer shall use the following engineering controls and work practices in all operations covered by this section, regardless of the levels of exposure. 1926.1101, G1, I, through 1926.1101, G1, 3. Vacuum cleaners equipped with HEPA filters to collect all debris and dust containing ACM and PCM, except as provided in paragraph G. 8, 2 of this section in the case of roofing material. Wet methods, or wetting agents, to control employee exposures during asbestos handling, mixing, removal, cutting, application, and cleanup, except where employers demonstrate that the use of wet methods is infeasible due to, for example, the creation of electrical hazards, equipment malfunction, and, in roofing, except as provided in paragraph G8(2) of this section, and prompt cleanup and disposal of wastes and debris contaminated with asbestos in leak-tight containers except in roofing operations, where the procedures specified in paragraph G8(2) of this section apply. 1926.1101 G2. In addition to the requirements of paragraph G1 of this section, the employer shall use the following control methods to achieve compliance with the TWA permissible exposure limit and excursion limit prescribed by paragraph C of this section. 1926.1101 G2I through 1926.1101 G2 the local exhaust ventilation equipped with HEPA filter dust collection systems, enclosure or isolation of processes producing asbestos dust, ventilation of the regulated area to move contaminated air away from the breathing zone of employees and toward a filtration or collection device equipped with a HEPA filter, use of other work practices and engineering controls that the Assistant Secretary can show to be feasible. Wherever the feasible engineering and work practice controls described above are not sufficient to reduce employee exposure to or below the permissible exposure limit and/or excursion limit prescribed in paragraph C of this section, the employer shall use them to reduce employee exposure to the lowest levels attainable by these controls and shall supplement them by the use of respiratory protection that complies with the requirements of paragraph H of this section. 1926.1101 G3 Prohibitions. The following work practices and engineering controls shall not be used for work related to asbestos or for work which disturbs ACM or PCM, regardless of measured levels of asbestos exposure or the results of initial exposure assessments. 1926.1101 G3I through 1926.1101 G3-4 high-speed abrasive disc saws that are not equipped with point-of-cut ventilator or enclosures with HEPA-filtered exhaust air. Compressed air used to remove asbestos, or materials containing asbestos, unless the compressed air is used in conjunction with an enclosed ventilation system designed to capture the dust cloud created by the compressed air. Dry sweeping, shoveling or other dry cleanup of dust and debris containing ACM and PCM. Employee rotation as a means of reducing employee exposure to asbestos. 1926.1101 G4 Class 1 Requirements. In addition to the provisions of paragraphs G1 and 2 of this section, the following engineering controls and work practices and procedures shall be used. 1926.1101 G4I. All Class 1 work, including the installation and operation of the control system, shall be supervised by a competent person as defined in paragraph B of this section. 1926.1101 G4-2. For all Class 1 jobs involving the removal of more than 25 linear or 10 square feet of thermal system insulation or surfacing material. For all other Class 1 jobs, where the employer cannot produce a negative exposure assessment pursuant to paragraph F2-3 of this section, or where employees are working in areas adjacent to the regulated area, while the Class 1 work is being performed, the employer shall use one of the following methods to ensure that airborne asbestos does not migrate from the regulated area. 1926.1101 G4-2A. Critical barriers shall be placed over all the openings to the regulated area, except where activities are performed outdoors, or 1926.1101 G4-2B. The employer shall use another barrier or isolation method which prevents the migration of airborne asbestos from the regulated area, as verified by perimeter area surveillance during each work shift at each boundary of the regulated area, showing no visible asbestos dust, and perimeter area monitoring showing that clearance levels contained in 40 CFR Part 763, Subt. E of the EPA asbestos in schools rule are met, or that perimeter area levels, measured by phase contrast microscopy, PCM, are no more than background levels representing the same area before the asbestos work began. The results of such monitoring shall be made known to the employer no later than 24 hours from the end of the work shift represented by such monitoring. Exception, for work completed outdoors where employees are not working in areas adjacent to the regulated areas, this paragraph, G4-2, is satisfied when the specific control methods in paragraph G5 of this section are used. 1926.1101 G4-3. For all Class 1 jobs, HVAC systems shall be isolated in the regulated area by sealing with a double layer of 6 mil plastic or the equivalent. 1926.1101 G4 For all Class 1 jobs, impermeable drop cloths shall be placed on surfaces beneath all removal activity. 1926.1101 G4V For all Class 1 jobs, all objects within the regulated area shall be covered with impermeable drop cloths or plastic sheeting which is secured by duct tape or an equivalent. 1926.1101 G4-6 For all Class 1 jobs where the employer cannot produce a negative exposure assessment, or where exposure monitoring shows that a PL is exceeded, the employer shall ventilate the regulated area to move contaminated air away from the breathing zone of employees toward a HEPA filtration or collection device. 1926.1101 G5 Specific control methods for Class 1 work. In addition, Class 1 asbestos work shall be performed using one or more of the following control methods pursuant to the limitations stated below. 1926.1101 G5I Negative pressure enclosure (NP) systems. NP systems may be used where the configuration of the work area does not make the erection of the enclosure infeasible, with the following specifications and work practices. 1926.1101 G5IA Specifications. 1926.1101 G5IA1 through 1926.1101 G5IA5 The negative pressure enclosure (NPE) may be of any configuration. At least 4 air changes per hour shall be maintained in the NPE. A minimum of -0.02 column inches of water pressure differential relative to outside pressure shall be maintained within the NP as evidenced by manometric measurements. The NPE shall be kept under negative pressure throughout the period of its use, and air movement shall be directed away from employees performing asbestos work within the enclosure and toward a HEPA filtration or a collection device. 1926.1101 G5IB Work Practices. 1926.1101 G5IB1 through 1926.1101 G5IB2 Before beginning work within the enclosure and at the beginning of each shift, the NPE shall be inspected for breaches and smoke tested for leaks, and any leaks sealed. Electrical circuits in the enclosure shall be deactivated, unless equipped with ground fault circuit interrupters. 1926.1101 G5-2 Glove bag systems may be used to remove PCM and/or ACM from straight runs of piping and elbows and other connections with the following specifications and work practices. 1926.1101 G5-2A Specifications. 1926.1101 G5-2A1 through A2 Glove bags shall be made of 6 mm thick plastic and shall be seamless at the bottom. Glove bags used on elbows and other connections must be designed for that purpose and used without modifications. 1926.1101 G5-2B Work Practices. 1926.1101 G5-2B1 through 1926.1101 G5-2B9 Each glove bag shall be installed so that it completely covers the circumference of pipe or other structure where the work is to be done. Glove bags shall be smoke tested for leaks and any leaks sealed prior to use. Glove bags may be used only once and may not be moved. Glove bags shall not be used on surfaces whose temperature exceeds 150 degrees Fahrenheit. Prior to disposal, glove bags shall be collapsed by removing air within them using a HEPA vacuum. Before beginning the operation, loose and friable material adjacent to the glove bag/box operation shall be wrapped and sealed in 2 layers of 6 mm plastic or otherwise rendered intact. Where system uses attached waste bag, such bag shall be connected to collection bag using hose or other material which shall withstand pressure of ACM waste and water without losing its integrity. Sliding valve or other device shall separate waste bag from hose to ensure no exposure when waste bag is disconnected. At least 2 persons shall perform Class 1 glove bag removal operations. 1926.1101 G5-3 Negative pressure glove bag systems. Negative pressure glove bag systems may be used to remove ACM or PACM from piping. 1926.1101 G5-3A Specifications. In addition to specifications for glove bag systems above, negative pressure glove bag systems shall attach HEPA vacuum systems or other devices to bag to prevent collapse during removal. 1926.1101 G5-3B Work Practices. 1926.1101 G5 3B1 through 1926.1101 G5 3B3, the employer shall comply with the work practices for glove bag systems in paragraph G5 2B4 of this section. The HEPA vacuum cleaner or other device used to prevent collapse of bag during removal shall run continually during the operation until it is completed, at which time the bag shall be collapsed prior to removal of the bag from the pipe. Where a separate waste bag is used along with a collection bag and discarded after one use, the collection bag may be reused if rinsed clean with amended water before reuse. 1926.1101 G5 4 Negative pressure glove box systems. Negative pressure glove boxes may be used to remove ACM or PACM from pipe runs with the following specifications and work practices. 1926.1101 G5 4A Specifications. 1926.1101 G5 4A1 through 1926.1101 G5 4A7 Glove boxes shall be constructed with rigid sides and made from metal or other material which can withstand the weight of the ACM and PACM and water used during removal. A negative pressure generator shall be used to create negative pressure in the system. An air filtration unit shall be attached to the box. The box shall be fitted with gloved apertures. An aperture at the base of the box shall serve as a bagging outlet for waste ACM and water. A backup generator shall be present on site. Waste bags shall consist of 6 mm thick plastic double-bagged before they are filled, or plastic thicker than 6 mm. 1926.1101 G5 4B Work Practices. 1926.1101 G5 4B1 through 1926.1101 G5 4B4 At least 2 persons shall perform the removal. The box shall be smoke tested for leaks and any leaks sealed prior to each use. Loose or damaged ACM adjacent to the box shall be wrapped and sealed in 2 layers of 6 mm plastic prior to the job, or otherwise made intact prior to the job. A HEPA filtration system shall be used to maintain pressure barrier in box. 1926.1101 G5V Water Spray Process System. A water spray process system may be used for removal of ACM and PACM from cold line piping if employees carrying out such process have completed a 40-hour separate training course in its use, in addition to training required for employees performing Class 1 work. The system shall meet the following specifications and shall be performed by employees using the following work practices. 1926.1101 G5VA Specifications. 1926.1101 G5VA1 through 1926.1101 G5VA3 Piping shall be surrounded on 3 sides by rigid framing. A 360-degree water spray, delivered through nozzles supplied by a high-pressure separate water line, shall be formed around the piping. The spray shall collide to form a fine aerosol which provides a liquid barrier between workers and the ACM and PACM. 1926.1101 G5VB Work Practices. 1926.1101 G5VB1 through 1926.1101 G5VB4 The system shall be run for at least 10 minutes before removal begins. All removal shall take place within the water barrier. The system shall be operated by at least 3 persons, one of whom shall not perform removal, but shall check equipment and ensure proper operation of the system. After removal, the ACM and PACM shall be bagged while still inside the water barrier. 1926.1101 G5-6 A small walk-in enclosure which accommodates no more than 2 persons, mini enclosure, may be used if the disturbance or removal can be completely contained by the enclosure with the following specifications and work practices. 1926.1101 G5-6A Specifications. 1926.1101 G5-6A1 through 1926.1101 G5-6A2 The fabricated or job-made enclosure shall be constructed of 6 mm plastic or equivalent. The enclosure shall be placed under negative pressure by means of a HEPA-filtered vacuum or similar ventilation unit. 1926.1101 G5-6B Work Practices. 1926.1101 G5-6B1 through 1926.1101 G5-6B3 Before use, the mini enclosure shall be inspected for leaks and smoke tested to detect breaches, and any breaches sealed. Before reuse, the interior shall be completely washed with amended water and HEPA vacuumed. During use, air movement shall be directed away from the employee's breathing zone within the mini enclosure. 1926.1101 G6 Alternative control methods for Class 1 work. Class 1 work may be performed using a control method which is not referenced in paragraph G5 of this section, or which modifies a control method referenced in paragraph G5 of this section if the following provisions are complied with. 1926.1101 G6 I. The control method shall enclose, contain or isolate the processes or source of airborne asbestos dust, or otherwise capture or redirect such dust before it enters the breathing zone of employees. 1926.1101 G6 2. A certified industrial hygienist or licensed professional engineer who is also qualified as a project designer as defined in paragraph B of this section shall evaluate the work area, the projected work practices and the engineering controls and shall certify in writing that the planned control method is adequate to reduce direct and indirect employee exposure to below the PLs under worst-case conditions of use, and that the planned control method will prevent asbestos contamination outside the regulated area, as measured by clearance sampling which meets the requirements of EPA's Asbestos in Schools rule issued under AHERA, or perimeter monitoring which meets the criteria in paragraph G4(2)(b) of this section. 1926.1101 G6(2)(a), where the TSI or surfacing material to be removed is 25 linear or 10 square feet or less. The evaluation required in paragraph G6 of this section may be performed by a competent person, and may omit consideration of perimeter or clearance monitoring otherwise required. 1926.1101 G6(2)(b). The evaluation of employee exposure required in paragraph G6 of this section shall include and be based on sampling and analytical data representing employee exposure during the use of such method under worst-case conditions and by employees whose training and experience are equivalent to employees who are to perform the current job. 1926.1101 G7 Work practices and engineering controls for Class 2 work. 1926.1101 G7 I. All Class 2 work shall be supervised by a competent person as defined in paragraph B of this section. 1926.1101 G7 2. For all indoor Class 2 jobs, where the employer has not produced a negative exposure assessment pursuant to paragraph F2(3) of this section, or where during the job, changed conditions indicate there may be exposure above the PL, or where the employer does not remove the ACM in a substantially intact state, the employer shall use one of the following methods to ensure that airborne asbestos does not migrate from the regulated area. 1926.1101 G7 2A through 1926.1101 G7 2C. Critical barriers shall be placed over all openings to the regulated area, or the employer shall use another barrier or isolation method which prevents the migration of airborne asbestos from the regulated area, as verified by perimeter area monitoring or clearance monitoring which meets the criteria set out in paragraph G4(2)(b) of this section. Impermeable drop cloths shall be placed on surfaces beneath all removal activity. 1926.1101 G7 3 Reserved. 1926.1101 G7 4 All Class 2 asbestos work shall be performed using the work practices and requirements set out above in paragraph G1I through G1(3) of this section. 1926.1101 G8 Additional controls for Class 2 work. Class 2 asbestos work shall also be performed by complying with the work practices and controls designated for each type of asbestos work to be performed, set out in this paragraph. Where more than one control method may be used for a type of asbestos work, the employer may choose one or a combination of designated control methods. Class 2 work also may be performed using a method allowed for Class 1 work, except that glove bags and glove boxes are allowed if they fully enclose the Class 2 material to be removed. 1926.1101 G8I For removing vinyl and asphalt flooring materials which contain ACM or for which in buildings constructed no later than 1980, the employer has not verified the absence of ACM pursuant to paragraph G8II of this section. The employer shall ensure that employees comply with the following work practices and that employees are trained in these practices pursuant to paragraph K9. 1926.1101 G8 I.A. through 1926.1101 G8 I. Flooring or its backing shall not be sanded. Vacuums equipped with HEPA filter, disposable dust bag, and metal floor tool, no brush, shall be used to clean floors. Resilient sheeting shall be removed by cutting with wetting of the snip point and wetting during delamination. Rip-up of resilient sheet floor material is prohibited. All scraping of residual adhesive and/or backing shall be performed using wet methods. Dry sweeping is prohibited. Mechanical chipping is prohibited unless performed in a negative pressure enclosure which meets the requirements of paragraph G5I of this section. Tiles shall be removed intact, unless the employer demonstrates that intact removal is not possible. When tiles are heated and can be removed intact, wetting may be omitted. Resilient flooring material including associated mastic and backing shall be assumed to be asbestos-containing unless an industrial hygienist determines that it is asbestos-free using recognized analytical techniques. 1926.1101 G8.2 For removing roofing material which contains ACM, the employer shall ensure that the following work practices are followed. 1926.1101 G8.2a through 1926.1101 G8.2d Roofing material shall be removed in an intact state to the extent feasible. What method shall be used to remove roofing materials that are not intact, or that will be rendered not intact during removal, unless such wet methods are not feasible or will create safety hazards? Cutting machines shall be continuously misted during use, unless a competent person determines that misting substantially decreases worker safety. When removing built-up roofs with asbestos-containing roofing felts and an aggregate surface using a power roof cutter, all dust resulting from the cutting operation shall be collected by a HEPA dust collector, or shall be HEPA vacuumed by vacuuming along the cut line. When removing built-up roofs with asbestos-containing roofing felts and a smooth surface using a power roof cutter, the dust resulting from the cutting operation shall be collected either by a HEPA dust collector or HEPA vacuuming along the cut line, or by gently sweeping and then carefully and completely wiping up the still wet dust and debris left along the cut line. The dust and debris shall be immediately bagged or placed in covered containers. 1926.1101 G8.2e Asbestos-containing material that has been removed from a roof shall not be dropped or thrown to the ground. Unless the material is carried or passed to the ground by hand, it shall be lowered to the ground via covered, dust-tight chute, crane or hoist. 1926.1101 G8.2e1 through 1926.1101 G8.2e2 Any ACM that is not intact shall be lowered to the ground as soon as is practicable, but in any event no later than the end of the work shift. While the material remains on the roof, it shall either be kept wet, placed in an impermeable waste bag, or wrapped in plastic sheeting. Intact ACM shall be lowered to the ground as soon as is practicable, but in any event no later than the end of the work shift. 1926.1101 G8.2f Upon being lowered, unwrapped material shall be transferred to a closed receptacle in such manner so as to preclude the dispersion of dust. 1926.1101 G8.2g Roof-level heating and ventilation air intake sources shall be isolated or the ventilation system shall be shut down. 1926.1101 G8.2h Notwithstanding any other provision of this section, removal or repair of sections of intact roofing less than 25 square feet in area does not require use of wet methods or HEPA vacuuming as long as manual methods which do not render the material non-intact are used to remove the material and no visible dust is created by the removal method used. In determining whether a job involves less than 25 square feet, the employer shall include all removal and repair work performed on the same roof on the same day. 1926.1101 G8.3 When removing cementitious asbestos-containing siding and shingles or transite panels containing ACM on building exteriors, other than roofs, where paragraph G8.2 of this section applies, the employer shall ensure that the following work practices are followed. 1926.1101 G8.3a through 1926.1101 G8.3d cutting, abrading or breaking siding, shingles, or transite panels shall be prohibited unless the employer can demonstrate that methods less likely to result in asbestos fiber release cannot be used. Each panel or shingle shall be sprayed with amended water prior to removal. Unwrapped or unbagged panels or shingles shall be immediately lowered to the ground via covered dust-tight chute, crane or hoist, or placed in an impervious waste bag or wrapped in plastic sheeting and lowered to the ground no later than the end of the work shift. Nails shall be cut with flat, sharp instruments. 1926.1101 G. 8.4. When removing gaskets containing ACM, the employer shall ensure that the following work practices are followed. 1926.1101 G. 8.4a through 1926.1101 G. 8.4d. If a gasket is visibly deteriorated and unlikely to be removed intact, removal shall be undertaken within a glove bag as described in paragraph G. 5.2 of this section. Reserved, the gasket shall be immediately placed in a disposal container. Any scraping to remove residue must be performed wet. 1926.1101 G. 8v. When performing any other Class II removal of asbestos containing material for which specific controls have not been listed in paragraph G. 8i through 4 of this section, the employer shall ensure that the following work practices are complied with. 1926.1101 G. 8v. through 1926.1101 G. 8v. The material shall be thoroughly wetted with amended water prior to and during its removal. The material shall be removed in an intact state unless the employer demonstrates that intact removal is not possible. Cutting, abrading, or breaking the material shall be prohibited unless the employer can demonstrate that methods less likely to result in asbestos fiber release are not feasible. Asbestos-containing material removed shall be immediately bagged or wrapped, or kept wetted until transferred to a closed receptacle, no later than the end of the work shift. 1926.1101 G. 8.6. Alternative work practices and controls. Instead of the work practices and controls listed in paragraph G. 8i through v of this section, the employer may use different or modified engineering and work practice controls if the following provisions are complied with. 1926.1101 G. 8.6a. The employer shall demonstrate by data representing employee exposure during the use of such method under conditions which closely resemble the conditions under which the method is to be used, that employee exposure will not exceed the PLs under any anticipated circumstances. 1926.1101 G. 8.6b. A competent person shall evaluate the work area, the projected work practices, and the engineering controls, and shall certify in writing that the different or modified controls are adequate to reduce direct and indirect employee exposure to below the PLs under all expected conditions of use and that the method meets the requirements of this standard. The evaluation shall include and be based on data representing employee exposure during the use of such method under conditions which closely resemble the conditions under which the method is to be used for the current job, and by employees whose training and experience are equivalent to employees who are to perform the current job. 1926.1101 G. 9. Work practices and engineering controls for Class III asbestos work. Class III asbestos work shall be conducted using engineering and work practice controls which minimize the exposure to employees performing the asbestos work and to bystander employees. 1926.1101 G. 9i through 1926.1101 G. 9v. The work shall be performed using wet methods. To the extent feasible, the work shall be performed using local exhaust ventilation. Where the disturbance involves drilling, cutting, abrading, sanding, chipping, breaking, or sawing of thermal system insulation or surfacing material, the employer shall use impermeable drop cloths and shall isolate the operation using mini enclosures or glove bag systems pursuant to paragraph G. 5 of this section or another isolation method. Where the employer does not produce a negative exposure assessment for a job, or where monitoring results show the PL has been exceeded, the employer shall contain the area using impermeable drop cloths and plastic barriers or their equivalent, or shall isolate the operation using a control system listed in and in compliance with paragraph G. 5 of this section. Employees performing Class III jobs, which involve the disturbance of thermal system insulation or surfacing material, or where the employer does not produce a negative exposure assessment, or where monitoring results show a PL has been exceeded, shall wear respirators which are selected, used, and fitted pursuant to provisions of paragraph H of this section. 1926.1101 G. 10. Class 4 Asbestos work. Class 4 asbestos jobs shall be conducted by employees trained pursuant to the Asbestos Awareness Training Program set out in paragraph K. 9 of this section. In addition, all Class 4 jobs shall be conducted in conformity with the requirements set out in paragraph G. 1 of this section, mandating wet methods, HEPA vacuums, and prompt cleanup of debris containing ACM or PACM. 1926.1101 G. 10 I through 1926.1101 G. 10 2. Employees cleaning up debris and waste in a regulated area where respirators are required shall wear respirators which are selected, used, and fitted pursuant to provisions of paragraph H of this section. Employers of employees who clean up waste and debris in, and employers in control of, areas where friable thermal system insulation or surfacing material is accessible, shall assume that such waste and debris contain asbestos. 1926.1101 G. 11. Alternative methods of compliance for installation, removal, repair, and maintenance of certain roofing and pipeline coating materials. Notwithstanding any other provision of this section, an employer who complies with all provisions of this paragraph, G. 11, when installing, removing, repairing, or maintaining intact pipeline asphaltic wrap, or roof flashings which contain asbestos fibers encapsulated or coated by bituminous or resinous compounds shall be deemed to be in compliance with this section. If an employer does not comply with all provisions of this paragraph, G. 11, or if during the course of the job the material does not remain intact, the provisions of paragraph G. 8 of this section apply instead of this paragraph G. 11. 1926.1101 G. 11 I. Before work begins and is needed during the job, a competent person who is capable of identifying asbestos hazards in the workplace and selecting the appropriate control strategy for asbestos exposure, and who has the authority to take prompt corrective measures to eliminate such hazards, shall conduct an inspection of the worksite and determine that the roofing material is intact and will likely remain intact. 1926.1101 G. 11 2. All employees performing work covered by this paragraph, G. 11, shall be trained in a training program that meets the requirements of paragraph K. 9, 8 of this section. 1926.1101 G. 11 3 through 1926.1101 G. 11 6. The material shall not be sanded, abraded, or ground. Manual methods which do not render the material non-intact shall be used. Material that has been removed from a roof shall not be dropped or thrown to the ground. Unless the material is carried or passed to the ground by hand, it shall be lowered to the ground via covered, dust-tight chute, crane or hoist. All such material shall be removed from the roof as soon as is practicable, but in any event no later than the end of the work shift. Where roofing products which have been labeled as containing asbestos pursuant to paragraph K. 8 of this section are installed on non-residential roofs during operations covered by this paragraph, G. 11, the employer shall notify the building owner of the presence and location of such materials no later than the end of the job. All removal or disturbance of pipeline asphaltic wrap shall be performed using wet methods. 1926.1101 H. Respiratory protection. 1926.1101 H. 1. General. For employees who use respirators required by this section, the employer must provide each employee an appropriate respirator that complies with the requirements of this paragraph. Respirators must be used during 1926.1101 H. 1 I through 1926.1101 H. 1 8. Class 1 asbestos work. Class 2 asbestos work when ACM is not removed in a substantially intact state. Class 2 and 3 asbestos work that is not performed using wet methods, except for removal of ACM from sloped roofs when a negative exposure assessment has been conducted and ACM is removed in an intact state. Class 2 and 3 asbestos work for which a negative exposure assessment has not been conducted. Class 3 asbestos work when TSI or surfacing ACM or PACM is being disturbed. Class 4 asbestos work performed within regulated areas where employees who are performing other work are required to use respirators. Work operations covered by this section for which employees are exposed above the TWA or excursion limit. Emergencies. 1926.1101, H2, Respirator Program. 1926.1101, H2, I. The employer must implement a respiratory protection program in accordance with Section 1910.134, B through D, except D, 1, 3, and F through M, which covers each employee required by this section to use a respirator. 1926.1101, H2, 2. No employee shall be assigned to asbestos work that requires respirator use if, based on their most recent medical examination, the examining physician determines that the employee will be unable to function normally while using a respirator, or that the safety or health of the employee or other employees will be impaired by the employee's respirator use. Such employees must be assigned to another job or given the opportunity to transfer to a different position that they can perform. If such a transfer position is available, it must be with the same employer, in the same geographical area, and with the same seniority, status, rate of pay, and other job benefits the employee had just prior to such transfer. 1926.1101, H3, Respirator Selection. 1926.1101, H3, I. Employers must. 1926.1101, H3, I, A. through 1926.1101, H3, I, B, select and provide to employees the appropriate respirators specified in paragraph D, 3, I, A of 29 CFR 1910.134. However, employers must not select or use filtering facepiece respirators for use against asbestos fibers. Provide HEPA filters for powered and non-powered air purifying respirators. 1926.1101, H3, 2. Employers must provide an employee with tight-fitting, powered air purifying respirator, PAPR, instead of a negative pressure respirator selected according to paragraph H3, I, A of this standard when the employee chooses to use a PAPR and it provides adequate protection to the employee. 1926.1101, H3, 3. Employers must provide employees with an air purifying half mask respirator, other than a filtering facepiece respirator, whenever the employees perform. 1926.1101, H3, 3A through 1926.1101, H3, 3B, Class 2 or Class 3 asbestos work for which no negative exposure assessment is available. Class 3 asbestos work involving disturbance of TSI or surfacing ACM or PACM. 1926.1101, H3, 4. Employers must provide employees with. 1926.1101, H3, 4A. A tight-fitting powered air purifying respirator or a full face piece, supplied air respirator operated in the pressure demand mode and equipped with either HEPA egress cartridges or an auxiliary positive pressure, self-contained breathing apparatus, SCBA. Whenever the employees are in a regulated area performing Class 1 asbestos work for which a negative exposure assessment is not available and the exposure assessment indicates that the exposure level will be at or below 1F/cc as an 8-hour time-weighted average, TWA. 1926.1101, H3, 4B. A full facepiece supplied air respirator operated in the pressure demand mode and equipped with an auxiliary positive pressure SCBA whenever the employees are in a regulated area performing Class 1 asbestos work for which a negative exposure assessment is not available and the exposure assessment indicates that the exposure level will be above 1F/cc as an 8-hour TWA. 1926.1101, I. Protective clothing. 1926.1101, I-1, General. The employer shall provide or require the use of protective clothing, such as coveralls or similar whole-body clothing, head coverings, gloves, and foot coverings for any employee exposed to airborne concentrations of asbestos that exceed the TWA and or excursion limit prescribed in paragraph C of this section, or for which a required negative exposure assessment is not produced, or for any employee performing Class 1 operations which involve the removal of over 25 linear or 10 square feet of TSI or surfacing ACM and PACM. 1926.1101, I-2, Laundering. 1926.1101, I-2, I, through 1926.1101, I-2, the employer shall ensure that laundering of contaminated clothing is done so as to prevent the release of airborne asbestos in excess of the TWA or excursion limit prescribed in paragraph C of this section. Any employer who gives contaminated clothing to another person for laundering shall inform such person of the requirement in paragraph I-2 I of this section to effectively prevent the release of airborne asbestos in excess of the TWA and excursion limit prescribed in paragraph C of this section. 1926.1101 I. 3. Contaminated clothing. Contaminated clothing shall be transported in sealed impermeable bags or other closed, impermeable containers and be labeled in accordance with paragraph K of this section. 1926.1101 I. 4. Inspection of protective clothing. 1926.1101 I. 4 I. The competent person shall examine worksuits worn by employees at least once per workshift for rips or tears that may occur during performance of work. 1926.1101 I. 4 2. When rips or tears are detected while an employee is working, rips and tears shall be immediately mended, or the worksuit shall be immediately replaced. 1926.1101 J. Hygiene facilities and practices for employees. 1926.1101 J. 1. Requirements for employees performing Class 1 asbestos jobs involving over 25 linear or 10 square feet of TSI or surfacing ACM and PCM. 1926.1101 J. 1 I. Decontamination areas. The employer shall establish a decontamination area that is adjacent and connected to the regulated area for the decontamination of such employees. The decontamination area shall consist of an equipment room, shower area, and clean room in series. The employer shall ensure that employees enter and exit the regulated area through the decontamination area. 1926.1101 J. 1 I. A. Equipment room. The equipment room shall be supplied with impermeable, labeled bags and containers for the containment and disposal of contaminated protective equipment. 1926.1101 J. 1 I. B. Shower area. Shower facilities shall be provided which comply with 29 CFR 1910.141 D3 unless the employer can demonstrate that they are not feasible. The shower shall be adjacent both to the equipment room and the clean room, unless the employer can demonstrate that this location is not feasible. Where the employer can demonstrate that it is not feasible to locate the shower between the equipment room and the clean room, or where the work is performed outdoors, the employer shall ensure that employees 1926.1101 J. 1 I. B. 1 through 1926.1101 J. 1 I. B. 2 remove asbestos contamination from their worksuits in the equipment room using a HEPA vacuum before proceeding to a shower that is not adjacent to the work area, or remove their contaminated worksuits in the equipment room, then don clean worksuits, and proceed to a shower that is not adjacent to the work area. 1926.1101 J. 1 I. C. Clean change room. The clean room shall be equipped with a locker or appropriate storage container for each employee's use. When the employer can demonstrate that it is not feasible to provide a clean change area adjacent to the work area or where the work is performed outdoors, the employer may permit employees engaged in Class 1 asbestos jobs to clean their protective clothing with a portable HEPA-equipped vacuum before such employees leave the regulated area. Following showering, such employees, however, must then change into street clothing in clean change areas provided by the employer which otherwise meet the requirements of this section. 1926.1101 J. 1 2 Decontamination area entry procedures. The employer shall ensure that employees 1926.1101 J. 1 2 A through 1926.1101 J. 1 2 D enter the decontamination area through the clean room, remove and deposit street clothing within a locker provided for their use, and put on protective clothing and respiratory protection before leaving the clean room. Before entering the regulated area, the employer shall ensure that employees pass through the equipment room. 1926.1101 J. 1 3 Decontamination area exit procedures. The employer shall ensure that 1926.1101 J. 1 3 A through 1926.1101 J. 1 3 E before leaving the regulated area, employees shall remove all gross contamination and debris from their protective clothing. Employees shall remove their protective clothing in the equipment room and deposit the clothing in labeled impermeable bags or containers. Employees shall not remove their respirators in the equipment room. Employees shall shower prior to entering the clean room. After showering, employees shall enter the clean room before changing into street clothes. 1926.1101 J1 4. Lunch areas. Whenever food or beverages are consumed at the worksite where employees are performing Class 1 asbestos work, the employer shall provide lunch areas in which the airborne concentrations of asbestos are below the permissible exposure limit and/or excursion limit. 1926.1101 J2. Requirements for Class 1 work involving less than 25 linear or 10 square feet of TSI or surfacing ACM and PCM, and for Class 2 and Class 3 asbestos work operations where exposures exceed a PL or where there is no negative exposure assessment produced before the operation. 1926.1101 J2I through 1926.1101 J2 the employer shall establish an equipment room or area that is adjacent to the regulated area for the decontamination of employees and their equipment which is contaminated with asbestos, which shall consist of an area covered by an impermeable drop cloth on the floor or horizontal working surface. The area must be of sufficient size as to accommodate cleaning of equipment and removing personal protective equipment without spreading contamination beyond the area, as determined by visible accumulations. Work clothing must be cleaned with a HEPA vacuum before it is removed. All equipment and surfaces of containers filled with ACM must be cleaned prior to removing them from the equipment room or area. The employer shall ensure that employees enter and exit the regulated area through the equipment room or area. 1926.1101 J3. Requirements for Class 4 work. Employers shall ensure that employees performing Class 4 work within a regulated area comply with the hygiene practice required of employees performing work which has a higher classification within that regulated area. Otherwise, employers of employees cleaning up debris and material which is TSI or surfacing ACM or identified as PCM shall provide decontamination facilities for such employees which are required by paragraph J2 of this section. 1926.1101 J4. Smoking in work areas. The employer shall ensure that employees do not smoke in work areas where they are occupationally exposed to asbestos because of activities in that work area. 1926.1101 K. Communication of hazards. 1926.1101 K1. Hazard communication. 1926.1101 K1 I. This section applies to the communication of information concerning asbestos hazards in construction activities to facilitate compliance with this standard. Most asbestos-related construction activities involve previously installed building materials. Building owners often are the only and/or best sources of information concerning them. Therefore, they, along with employers of potentially exposed employees, are assigned specific information conveying and retention duties under this section. Installed asbestos containing building material. Employers and building owners shall identify TSI and sprayed or troweled on surfacing materials in buildings as asbestos containing, unless they determine in compliance with paragraph K5 of this section that the material is not asbestos containing. Asphalt and vinyl flooring material installed no later than 1980 must also be considered as asbestos containing unless the employer, pursuant to paragraph G8I of this section, determines that it is not asbestos containing. If the employer/building owner has actual knowledge, or should have known through the exercise of due diligence, that other materials are asbestos containing, they too must be treated as such. When communicating information to employees pursuant to this standard, owners and employers shall identify PCM as ACM. Additional requirements relating to communication of asbestos work on multi-employer worksites are set out in paragraph D of this section. 1926.1101 K1 2. The employer shall include asbestos in the program established to comply with the Hazard Communication Standard, HCS, section 1910.1200. The employer shall ensure that each employee has access to labels on containers of asbestos and safety data sheets, and is trained in accordance with the provisions of HCS in paragraphs K, 9, and 10 of this section. The employer shall provide information on at least the following hazards: cancer and lung effects. 1926.1101 K, 2. Duties of building and facility owners. 1926.1101 K, 2, I. Before work subject to this standard is begun, Building and facility owners shall determine the presence, location, and quantity of ACM and/or PACM at the worksite pursuant to paragraph K1I of this section. 1926.1101 K2 Building and/or facility owners shall notify the following persons of the presence, location, and quantity of ACM or PACM at the worksites in their buildings and facilities. Notification either shall be in writing, or shall consist of a personal communication between the owner and the person to whom notification must be given or their authorized representatives. 1926.1101 K2(a) through 1926.1101 K2(d). Prospective employers applying or bidding for work whose employees reasonably can be expected to work in or adjacent to areas containing such material. Employees of the owner who will work in or adjacent to areas containing such material. On multi-employer worksites, all employers of employees who will be performing work within or adjacent to areas containing such materials. Tenants who will occupy areas containing such material. 1926.1101 K3 Duties of employers whose employees perform work subject to this standard in or adjacent to areas containing ACM and PACM. Building/facility owners whose employees perform such work shall comply with these provisions to the extent applicable. 1926.1101 K3I Before work in areas containing ACM and PACM is begun, employers shall identify the presence, location, and quantity of ACM and/or PACM therein pursuant to paragraph K1I of this section. 1926.1101 K3(2) Before work under this standard is performed, employers of employees who will perform such work shall inform the following persons of the location and quantity of ACM and/or PACM present in the area and the precautions to be taken to ensure that airborne asbestos is confined to the area. 1926.1101 K3(2)a through 1926.1101 K3(2)b Owners of the building/facility. Employees who will perform such work and employers of employees who work and/or will be working in adjacent areas. Within 10 days of the completion of such work, the employer whose employees have performed work subject to this standard shall inform the building/facility owner and employers of employees who will be working in the area of the current location and quantity of PACM and/or ACM remaining in the area and final monitoring results, if any. 1926.1101 K4 In addition to the above requirements, all employers who discover ACM and/or PACM on a worksite shall convey information concerning the presence, location, and quantity of such newly discovered ACM and/or PACM to the owner and to other employers of employees working at the worksite within 24 hours of the discovery. 1926.1101 K5 Criteria to rebut the designation of installed material as PACM. 1926.1101 K5I At any time, an employer and/or building owner may demonstrate, for purposes of this standard, that PACM does not contain asbestos. Building owners and/or employers are not required to communicate information about the presence of building material for which such a demonstration pursuant to the requirements of paragraph K5(2) of this section has been made. However, in all such cases, the information, data, and analysis supporting the determination that PACM does not contain asbestos shall be retained pursuant to paragraph N of this section. 1926.1101 K5(2) An employer or owner may demonstrate that PACM does not contain more than 1% asbestos by the following. 1926.1101 K5(2)a Having a completed inspection conducted pursuant to the requirements of AHERA 40 CFR Part 763, Subpart E, which demonstrates that the material is not ACM, or 1926.1101 K5(2)b Performing tests of the material containing PACM which demonstrate that no ACM is present in the material. Such tests shall include analysis of bulk samples collected in the manner described in 40 CFR 763.86. The tests, evaluation, and sample collection shall be conducted by an accredited inspector or by a CIH. Analysis of samples shall be performed by persons or laboratories with proficiency demonstrated by current successful participation in a nationally recognized testing program such as the National Voluntary Laboratory Accreditation Program, NVLAP, or the National Institute for Standards and Technology, NIST, or the round robin for bulk samples administered by the American Industrial Hygiene Association, AIHA, or an equivalent nationally recognized round robin testing program. 1926.1101, K. 5, 3, the employer and/or building owner may demonstrate that flooring material, including associated mastic and backing, does not contain asbestos, by a determination of an industrial hygienist based upon recognized analytical techniques showing that the material is not ACM. 1926.1101, K. 6, at the entrance to mechanical rooms/areas in which employees reasonably can be expected to enter and which contain ACM and/or PCM, the building owner shall post signs which identify the material which is present, its location, and appropriate work practices which, if followed, will ensure that ACM and/or PCM will not be disturbed. The employer shall ensure, to the extent feasible, that employees who come in contact with these signs can comprehend them. Means to ensure employee comprehension may include the use of foreign languages, pictographs, graphics, and awareness training. 1926.1101, K. 7, signs. 1926.1101, K. 7, I. Warning signs that demarcate the regulated area shall be provided and displayed at each location where a regulated area is required to be established by paragraph E of this section. Signs shall be posted at such a distance from such a location that an employee may read the signs and take necessary protective steps before entering the area marked by the signs. 1926.1101, K. 7, 2, the warning signs required by paragraph K. 7 of this section shall bear the following information. 1926.1101, K. 7, 2, A, danger. Asbestos may cause cancer. Causes damage to lungs. Authorized personnel only. 1926.1101, K. 7, 2, B. In addition, where the use of respirators and protective clothing is required in the regulated area under this section, the warning signs shall include the following: wear respiratory protection and protective clothing in this area. 1926.1101, K. 7, 2, C. Prior to June 1, 2016, employers may use the following legend in lieu of that specified in paragraph K. 7, 2, A of this section: danger. Asbestos. Cancer and lung disease hazard. Authorized personnel only. 1926.1101, K. 7, 2, D. Prior to June 1, 2016, employers may use the following legend in lieu of that specified in paragraph K. 7, 2, B of this section: respirators and protective clothing are required in this area. 1926.1101, K. 7, 3, the employer shall ensure that employees working in and contiguous to regulated areas comprehend the warning signs required to be posted by paragraph K. 7, I of this section. Means to ensure employee comprehension may include the use of foreign languages, pictographs, and graphics. 1926.1101, K. 8, labels. 1926.1101, K. 8, I, through 1926.1101, K. 8, 3, labels shall be affixed to all products containing asbestos and to all containers containing such products, including waste containers. Where feasible, installed asbestos products shall contain a visible label. The employer shall ensure that such labels comply with paragraphs K of this section. The employer shall ensure that labels of bags or containers of protective clothing and equipment, scrap, waste, and debris containing asbestos fibers bear the following information: danger. Contains asbestos fibers. May cause cancer. Causes damage to lungs. Do not breathe dust. Avoid creating dust. 1926.1101, K. 8, 4, A. Prior to June 1, 2015, employers may include the following information on raw materials, mixtures or labels of bags or containers of protective clothing and equipment, scrap, waste, and debris containing asbestos fibers in lieu of the labeling requirements in paragraphs K. 8, 2 and K. 8, 3 of this section. Danger. Contains asbestos fibers. Avoid creating dust. Cancer and lung disease hazard. 1926.1101, K. 8, 4, B. Labels shall also contain a warning statement against breathing asbestos fibers. 1926.1101, K. 8, V. Reserved. 1926.1101, K. 8, 6. The provisions for labels required by paragraphs K. 8, I through K. 8, 3 of this section do not apply where 1926.1101 K8 6A through 1926.1101 K8 6B. Asbestos fibers have been modified by a bonding agent, coating, binder, or other material, provided that the manufacturer can demonstrate that, during any reasonably foreseeable use, handling, storage, disposal, processing, or transportation, no airborne concentrations of asbestos fibers in excess of the permissible exposure limit and/or excursion limit will be released, or asbestos is present in a product in concentrations less than 1%. 1926.1101 K8 7. When a building owner or employer identifies previously installed PCM and/or ACM, labels or signs shall be affixed or posted so that employees will be notified of what materials contain PCM and/or ACM. The employer shall attach such labels in areas where they will clearly be noticed by employees who are likely to be exposed, such as at the entrance to mechanical room/areas. Signs required by paragraph K6 of this section may be posted in lieu of labels so long as they contain information required for labeling. The employer shall ensure, to the extent feasible, that employees who come in contact with these signs or labels can comprehend them. Means to ensure employee comprehension may include the use of foreign languages, pictographs, graphics, and awareness training. 1926.1101 K9 Employee Information and Training. 1926.1101 K9I through 1926.1101 K9 3. The employer shall train each employee who is likely to be exposed in excess of a PL, and each employee who performs Class 1 through 4 asbestos operations, in accordance with the requirements of this section. Such training shall be conducted at no cost to the employee. The employer shall institute a training program and ensure employee participation in the program. Training shall be provided prior to or at the time of initial assignment and at least annually thereafter. Training for Class 1 operations and for Class 2 operations that require the use of critical barriers or equivalent isolation methods and/or negative pressure enclosures under this section shall be the equivalent in curriculum, training method, and length to the EPA Model Accreditation Plan, MAP, Asbestos Abatement Workers Training, 40 CFR Part 763, Subpart E, Appendix C. 1926.1101 K9 4. Training for other Class 2 work. 1926.1101 K9 4A through 1926.1101 K9 4C. For work with asbestos containing roofing materials, flooring materials, siding materials, ceiling tiles, or transite panels, training shall include at a minimum all the elements included in paragraph K9 8 of this section and in addition, the specific work practices and engineering controls set forth in paragraph G of this section which specifically relate to that category. Such course shall include hands-on training and shall take at least 8 hours. An employee who works with more than one of the categories of material specified in paragraph K9 4A of this section shall receive training in the work practices applicable to each category of material that the employee removes and each removal method that the employee uses. For Class 2 operations not involving the categories of material specified in paragraph K9 4A of this section, training shall be provided which shall include at a minimum all the elements included in paragraph K9 8 of this section and in addition, the specific work practices and engineering controls set forth in paragraph G of this section which specifically relate to the category of material being removed, and shall include hands-on training in the work practices applicable to each category of material that the employee removes and each removal method that the employee uses. 1926.1101 K9V. Training for Class 3 employees shall be consistent with EPA requirements for training of local education agency maintenance and custodial staff as set forth at 40 CFR 763.92, A2. Such a course shall also include hands-on training and shall take at least 16 hours. Exception, for Class 3 operations for which the competent person determines that the EPA curriculum does not adequately cover the training needed to perform that activity, training shall include as a minimum all the elements included in paragraph K9 8 of this section and in addition, the specific work practices and engineering controls set forth in paragraph G of this section which specifically relate to that activity, and shall include hands-on training in the work practices applicable to each category of material that the employee disturbs. 1926.1101 K9 6. Training for employees performing Class 4 operations shall be consistent with EPA requirements for training of local education agency maintenance and custodial staff as set forth at 40 CFR 763.92, A1. Such a course shall include available information concerning the locations of thermal system insulation and surfacing ACM/PCM, and asbestos-containing flooring material, or flooring material where the absence of asbestos has not yet been certified, and instruction in recognition of damage, deterioration, and delamination of asbestos-containing building materials. Such course shall take at least 2 hours. 1926.1101, K9-7, training for employees who are likely to be exposed in excess of the PL and who are not otherwise required to be trained under paragraph K9-3 through 6 of this section shall meet the requirements of paragraph K9-8 of this section. 1926.1101, K9-8, the training program shall be conducted in a manner that the employee is able to understand. In addition to the content required by provisions in paragraphs K9-3 through 6 of this section, the employer shall ensure that each such employee is informed of the following: 1926.1101, K9-8A through 1926.1101, K9-8J, methods of recognizing asbestos, including the requirement in paragraph K1 of this section to presume that certain building materials contain asbestos, the health effects associated with asbestos exposure, the relationship between smoking and asbestos in producing lung cancer, the nature of operations that could result in exposure to asbestos, the importance of necessary protective controls to minimize exposure including, as applicable, engineering controls, work practices, respirators, housekeeping procedures, hygiene facilities, protective clothing, decontamination procedures, emergency procedures, and waste disposal procedures, and any necessary instruction in the use of these controls and procedures. Where Class 3 and 4 work will be or is performed, the contents of EPA 20/2003, Managing Asbestos in Place, July 1990 or its equivalent in content. The purpose, proper use, fitting instructions, and limitations of respirators as required by 29 CFR 1910.134. The appropriate work practices for performing the asbestos job. Medical surveillance program requirements. The content of this standard, including appendices. The names, addresses and phone numbers of public health organizations which provide information, materials and/or conduct programs concerning smoking cessation. The employer may distribute the list of such organizations contained in Appendix J to this section to comply with this requirement, and the requirements for posting signs and affixing labels and the meaning of the required legends for such signs and labels. 1926.1101, K10, access to training materials. 1926.1101, K10, I. 1926.1101, K10, 3. The employer shall make readily available to affected employees without cost written materials relating to the employee training program, including a copy of this regulation. The employer shall inform all employees concerning the availability of self-help smoking cessation program material. Upon employee request, the employer shall distribute such material, consisting of NIH Publication No. 89-1647, or equivalent self-help material, which is approved or published by a public health organization listed in Appendix J to this section. 1926.1101, L. Housekeeping. 1926.1101, L1, Vacuuming. Where vacuuming methods are selected, HEPA-filtered vacuuming equipment must be used. The equipment shall be used and emptied in a manner that minimizes the re-entry of asbestos into the workplace. 1926.1101, L2, Waste disposal. Asbestos waste, scrap, debris, bags, containers, equipment, and contaminated clothing consigned for disposal shall be collected and disposed of in sealed, labeled, impermeable bags or other closed, labeled, impermeable containers except in roofing operations, where the procedures specified in paragraph G8(2) of this section apply. 1926.1101, L3, Care of asbestos-containing flooring material. 1926.1101, L3I, through 1926.1101, L3-4, all vinyl and asphalt flooring material shall be maintained in accordance with this paragraph unless the building/facility owner demonstrates, pursuant to paragraph G8I of this section, that the flooring does not contain asbestos. Sanding of flooring material is prohibited. Stripping of finishes shall be conducted using low abrasion pads at speeds lower than 300 rpm and wet methods. Burnishing or dry buffing may be performed only on flooring which has sufficient finish so that the pad cannot contact the flooring material. 1926.1101 L4. Waste and debris and accompanying dust in an area containing accessible thermal system insulation or surfacing ACM/PCM or visibly deteriorated ACM. 1926.1101 L4I through 1926.1101 L4-2 shall not be dusted or swept dry or vacuumed without using a HEPA filter, shall be promptly cleaned up and disposed of in leak-tight containers. 1926.1101 M. Medical surveillance. 1926.1101 M1 General. 1926.1101 M1I Employees covered. 1926.1101 M1I-A through 1926.1101 M1I-B. The employer shall institute a medical surveillance program for all employees who for a combined total of 30 or more days per year are engaged in Class 1, 2 and 3 work or are exposed at or above a permissible exposure limit. For purposes of this paragraph, any day in which a worker engages in Class 2 or Class 3 operations or a combination thereof on intact material for 1 hour or less, taking into account the entire time spent on the removal operation, including cleanup, and, while doing so, adheres fully to the work practices specified in this standard, shall not be counted. For employees otherwise required by this standard to wear a negative pressure respirator, employers shall ensure employees are physically able to perform the work and use the equipment. This determination shall be made under the supervision of a physician. 1926.1101 M1-2 Examination. 1926.1101 M1-2A through 1926.1101 M1-2B. The employer shall ensure that all medical examinations and procedures are performed by or under the supervision of a licensed physician and are provided at no cost to the employee and at a reasonable time and place. Persons other than such licensed physicians who administer the pulmonary function testing required by this section shall complete a training course in spirometry sponsored by an appropriate academic or professional institution. 1926.1101 M2 Medical examinations and consultations. 1926.1101 M2I Frequency. The employer shall make available medical examinations and consultations to each employee covered under paragraph M1I of this section on the following schedules: 1926.1101 M2IA through 1926.1101 M2IE, prior to assignment of the employee to an area where negative pressure respirators are worn. When the employee is assigned to an area where exposure to asbestos may be at or above the permissible exposure limit for 30 or more days per year, or engage in Class 1, 2, or 3 work for a combined total of 30 or more days per year, a medical examination must be given within 10 working days following the 30th day of exposure, and at least annually thereafter. If the examining physician determines that any of the examinations should be provided more frequently than specified, the employer shall provide such examinations to affected employees at the frequencies specified by the physician. Exception: no medical examination is required of any employee if adequate records show that the employee has been examined in accordance with this paragraph within the past 1-year period. 1926.1101 M2 the second Content. Medical examinations made available pursuant to paragraphs M2IA through M2IC of this section shall include 1926.1101 M22A through 1926.1101 M22D, a medical and work history with special emphasis directed to the pulmonary, cardiovascular, and gastrointestinal systems. On initial examination, the standardized questionnaire contained in Part 1 of Appendix D to this section, and, on annual examination, the abbreviated standardized questionnaire contained in Part 2 of Appendix D to this section. A physical examination directed to the pulmonary and gastrointestinal systems, including a 14 by 17 inch or other reasonably sized standard film or digital posterior anterior chest X-ray to be administered at the discretion of the physician, and pulmonary function tests of forced vital capacity, FVC, and forced expiratory volume at 1 second, FEV1. Classification of all chest X-rays shall be conducted in accordance with Appendix E to this section. Any other examinations or tests deemed necessary by the examining physician. 1926.1101 M3. Information provided to the physician. The employer shall provide the following information to the examining physician. 1926.1101 M3 I through 1926.1101 M3 V. A copy of this standard and Appendices D, E, and I to this section. A description of the affected employee's duties as they relate to the employee's exposure, the employee's representative exposure level or anticipated exposure level, a description of any personal protective and respiratory equipment used or to be used, and information from previous medical examinations of the affected employee that is not otherwise available to the examining physician. 1926.1101 M4. Physician's written opinion. 1926.1101 M4 I. The employer shall obtain a written opinion from the examining physician. This written opinion shall contain the results of the medical examination and shall include 1926.1101 M4 I A through 1926.1101 M4 I D. The physician's opinion as to whether the employee has any detected medical conditions that would place the employee at an increased risk of material health impairment from exposure to asbestos, any recommended limitations on the employee or on the use of personal protective equipment such as respirators, and a statement that the employee has been informed by the physician of the results of the medical examination and of any medical conditions that may result from asbestos exposure. A statement that the employee has been informed by the physician of the increased risk of lung cancer attributable to the combined effect of smoking and asbestos exposure. 1926.1101 M4 2. The employer shall instruct the physician not to reveal in the written opinion given to the employer specific findings or diagnoses unrelated to occupational exposure to asbestos. 1926.1101 M4 3. The employer shall provide a copy of the physician's written opinion to the affected employee within 30 days from its receipt. 1926.1101 N. Record keeping. 1926.1101 N1. Objective data relied on pursuant to paragraph F to this section. 1926.1101 N1 I. Where the employer has relied on objective data that demonstrates that products made from or containing asbestos or the activity involving such products or material are not capable of releasing fibers of asbestos in concentrations at or above the permissible exposure limit and/or excursion limit under the expected conditions of processing, use, or handling to satisfy the requirements of paragraph F. The employer shall establish and maintain an accurate record of objective data reasonably relied upon in support of the exemption. 1926.1101 N1 2. The record shall include at least the following information. 1926.1101 N1 2 A through 1926.1101 N1 2 E. The product qualifying for exemption, the source of the objective data, the testing protocol, results of testing, and/or analysis of the material for the release of asbestos, a description of the operation exempted and how the data support the exemption, and other data relevant to the operations, materials, processing, or employee exposures covered by the exemption. 1926.1101 N1 3. The employer shall maintain this record for the duration of the employer's reliance upon such objective data. 1926.1101 N2. Exposure measurements. 1926.1101 N2 I. The employer shall keep an accurate record of all measurements taken to monitor employee exposure to asbestos as prescribed in paragraph F of this section. Note: the employer may utilize the services of competent organizations such as industry trade associations and employee associations to maintain the records required by this section. 1926.1101 N2 2. This record shall include at least the following information. 1926.1101 N2 2 A through 1926.1101 N2 2 F. The date of measurement, the operation involving exposure to asbestos that is being monitored, sampling and analytical methods used in evidence of their accuracy, number, duration, and results of samples taken, type of protective devices worn, if any, and name and exposure of the employees whose exposures are represented. 1926.1101 N2 3. The employer shall maintain this record for at least 30 years, in accordance with Section 1910.1020 of this chapter. 1926.1101, N. 3. Medical surveillance. 1926.1101, N. 3. I. The employer shall establish and maintain an accurate record for each employee subject to medical surveillance by paragraph M of this section, in accordance with Section 1910.1020 of this chapter. 1926.1101, N. 3. 2. The record shall include at least the following information. 1926.1101, N. 3. 2. A. Through 1926.1101, N. 3. 2. E. The name of the employee. A copy of the employee's medical examination results, including the medical history, questionnaire responses, results of any tests, and physician's recommendations. Physician's written opinions, any employee medical complaints related to exposure to asbestos, and a copy of the information provided to the physician as required by paragraph M of this section. 1926.1101, N. 3. 3. The employer shall ensure that this record is maintained for the duration of employment plus 30 years, in accordance with Section 1910.1020 of this chapter. 1926.1101, N. 4. Training records. The employer shall maintain all employee training records for 1 year beyond the last date of employment by that employer. 1926.1101, N. 5. Data to rebut PACM. Where the building owner and employer have relied on data to demonstrate that PACM is not asbestos containing, such data shall be maintained for as long as they are relied upon to rebut the presumption. 1926.1101, N. 6. Records of required notifications. Where the building owner has communicated and received information concerning the identification, location, and quantity of ACM and PACM, written records of such notifications and their content shall be maintained by the building owner for the duration of ownership and shall be transferred to successive owners of such buildings/facilities. 1926.1101, N. 7. Availability. 1926.1101, N. 7. I. The employer, upon written request, shall make all records required to be maintained by this section available to the Assistant Secretary and the Director for examination and copying. 1926.1101, N. 7. 2. The employer must comply with the requirements concerning availability of records set forth in 29 CFR 1910.1020. 1926.1101, N. 8. Transfer of records. The employer must comply with the requirements concerning transfer of records set forth in 29 CFR 1910.1020 1926.1101, O. Competent person. 1926.1101, O1, General. On all construction work sites covered by this standard, the employer shall designate a competent person, having the qualifications and authorities for ensuring worker safety and health required by Subpart C, General Safety and Health Provisions for Construction, 29 CFR 1926.20 through 1926.32. 1926.1101, O2, Required inspections by the competent person. Section 1926.20, B2, which requires health and safety prevention programs to provide for frequent and regular inspections of the job sites, materials, and equipment to be made by competent persons, is incorporated. 1926.1101, O3, Additional inspections. In addition, the competent person shall make frequent and regular inspections of the job sites, in order to perform the duties set out below in paragraph O3I of this section. For Class 1 jobs, on-site inspections shall be made at least once during each work shift, and at any time at employee request. For Class 2, 3, and 4 jobs, on-site inspections shall be made at intervals sufficient to assess whether conditions have changed, and at any reasonable time at employee request. 1926.1101, O3I. On all work sites where employees are engaged in Class 1 or 2 asbestos work, the competent person designated in accordance with paragraph E6 of this section shall perform or supervise the following duties, as applicable. 1926.1101, O3I-A through 1926.1101, O3I-H. Set up the regulated area, enclosure, or other containment,
Ensure, by on-site inspection, the integrity of the enclosure or containment.
Set up procedures to control entry to and exit from the enclosure and/or area. Supervise all employee exposure monitoring required by this section and ensure that it is conducted as required by paragraph F of this section. Ensure that employees working within the enclosure and/or using glove bags wear respirators and protective clothing as required by paragraphs H and I of this section. Ensure through on-site supervision that employees set up, use, and remove engineering controls, use work practices and personal protective equipment in compliance with all requirements. Ensure that employees use the hygiene facilities and observe the decontamination procedures specified in paragraph J of this section. Ensure that through on-site inspection, engineering controls are functioning properly and employees are using proper work practices. And 1926.1101.03 I. Ensure that notification requirement in paragraph K of this section are met. 1926.1101.03.2 Reserved. 1926.1101.04 I. For Class 1 and 2 asbestos work, the competent person shall be trained in all aspects of asbestos removal and handling, including abatement, installation, removal and handling, the contents of this standard, the identification of asbestos, removal procedures, where appropriate, and other practices for reducing the hazard. Such training shall be obtained in a comprehensive course for supervisors that meets the criteria of EPA's Model Accreditation Plan, 40 CFR Part 763, Subpart E, Appendix C, such as a course conducted by an EPA-approved or state-approved training provider, certified by EPA or a state, or a course equivalent in stringency, content, and length. 1926.1101.04.2 For Class 3 and 4 asbestos work, the competent person shall be trained in aspects of asbestos handling appropriate for the nature of the work, to include procedures for setting up glove bags in mini enclosures, practices for reducing asbestos exposures, use of wet methods, the contents of this standard, and the identification of asbestos. Such training shall include successful completion of a course that is consistent with EPA requirements for training of local education agency maintenance and custodial staff as set forth at 40 CFR 763.92, A2, or its equivalent in stringency, content and length. Competent persons for Class 3 and 4 work may also be trained pursuant to the requirements of paragraph 0.4 of this section. 1926.1101 P. Appendices. 1926.1101 P1 Appendices A, D, and E to this section are incorporated as part of this section, and the contents of these appendices are mandatory. 1926.1101 P2 Appendices B, F, H, I, J, and K to this section are informational and are not intended to create any additional obligations not otherwise imposed or to detract from any existing obligations. 1926.1101 Appendix A OSHA Reference Method, Mandatory. 1926.1101 Appendix A OSHA Reference Method, Mandatory. 3. An airflow rate between 0.5 liter/min and 2.5 liters/min shall be selected for the 25/mm cassette. If the 37 mm cassette is used, an airflow rate between 1 liter/min and 2.5 liters/min shall be selected. 4. Where possible, a sufficient air volume for each air sample shall be collected to yield between 100 and 1,300 fibers per square millimeter on the membrane filter. If a filter darkens in appearance or if loose dust is seen on the filter, a second sample shall be started. 5. Ship the samples in a rigid container with sufficient packing material to prevent dislodging the collected fibers. Packing material that has a high electrostatic charge on its surface, e.g., expanded polystyrene, cannot be used because such material can cause loss of fibers to the sides of the cassette. 6. Calibrate each personal sampling pump before and after use with a representative filter cassette installed between the pump and the calibration devices. 7. Personal samples shall be taken in the breathing zone of the employee, i.e., attached to or near the collar or lapel near the worker's face. 8. Fiber counts shall be made by positive phase contrast using a microscope with an 8 to 10 times eyepiece and a 40 to 45 times objective for a total magnification of approximately 400 times and a numerical aperture of 0.65 to 0.75. The microscope shall also be fitted with a green or blue filter. 9. The microscope shall be fitted with a Walton-Beckett eyepiece graticule calibrated for a field diameter of 100 micrometers, plus or minus 2 micrometers. 10. The phase shift detection limit of the microscope shall be about 3 degrees measured using the HSE phase shift test slide as outlined below. A. Place the test slide on the microscope stage and center it under the phase objective. B. Bring the blocks of groove lines into focus. Note, the slide consists of 7 sets of groove lines, ca. 20 grooves to each block, in descending order of visibility from sets 1 to 7, 7 being the least visible. The requirements for asbestos counting are that the microscope optics must resolve the groove lines in set 3 completely, although they may appear somewhat faint, and that the groove lines in sets 6 and 7 must be invisible. Sets 4 and 5 must be at least partially visible but may vary slightly in visibility between microscopes. A microscope that fails to meet these requirements has either too low or too high a resolution to be used for asbestos counting. C. If the image deteriorates, clean and adjust the microscope optics. If the problem persists, consult the microscope manufacturer. 11. Each set of samples taken will include 10% field blanks or a minimum of 2 field blanks. These blanks must come from the same lot as the filters used for sample collection. The field blank results shall be averaged and subtracted from the analytical results before reporting. A set consists of any sample or group of samples for which an evaluation for this standard must be made. Any samples represented by a field blank having a fiber count in excess of the detection limit of the method being used shall be rejected. 12. The sample shall be mounted by the acetone/triacetin method or a method with an equivalent index of refraction and similar clarity. 13. Observe the following counting rules. A. Count only fibers equal to or longer than 5 micrometers. Measure the length of curved fibers along the curve. B. In the absence of other information, count all particles as asbestos that have a length-to-width ratio, aspect ratio, of 3 to 1 or greater. C. Fibers lying entirely within the boundary of the Walton-Beckett graticule field shall receive a count of 1. Fibers crossing the boundary once, having one end within the circle, shall receive the count of 1/2, 1/2. Do not count any fiber that crosses the graticule boundary more than once. Reject and do not count any other fibers even though they may be visible outside the graticule area. D. Count bundles of fibers as one fiber unless individual fibers can be identified by observing both ends of an individual fiber. E. Count enough graticule fields to yield 100 fibers. Count a minimum of 20 fields, stop counting at 100 fields regardless of fiber count. 14. Blind recounts shall be conducted at the rate of 10%. Quality control procedures. 1. Intra-laboratory program. Each laboratory and/or each company with more than one microscopist counting slides shall establish a statistically designed quality assurance program involving blind recounts and comparisons between microscopists to monitor the variability of counting by each microscopist and between microscopists. In a company with more than one laboratory, the program shall include all laboratories and shall also evaluate the laboratory-to-laboratory variability. 2. An interlaboratory program. Each laboratory analyzing asbestos samples for compliance determination shall implement an interlaboratory quality assurance program that, as a minimum, includes participation of at least 2 other independent laboratories. Each laboratory shall participate in round-robin testing at least once every 6 months with at least all the other laboratories in its interlaboratory quality assurance group. Each laboratory shall submit slides typical of its own workload for use in this program. The round-robin shall be designed and results analyzed using appropriate statistical methodology. B. All laboratories should also participate in a national sample testing scheme such as the Proficiency Analytical Testing Program, PATI, or the Asbestos Registry sponsored by the American Industrial Hygiene Association, AIHA. 3. All individuals performing asbestos analysis must have taken the NIOSH course for sampling and evaluating airborne asbestos dust or an equivalent course. 4. When the use of different microscopes contributes to differences between counters and laboratories, the effect of the different microscope shall be evaluated and the microscope shall be replaced, as necessary. 5.
Current results of these quality assurance programs shall be posted in each laboratory to keep the microscopists informed. 1926.1101 Appendix B. Sampling and Analysis Non-Mandatory. Matrix Air, OSHA Permissible Exposure Limits. Time-weighted average is 0.1 fiber/cc.
Excursion level, 30 minutes, is 1.0 fiber/cc. A known volume of air is drawn through a 25 mm diameter cassette containing a mixed cellulose ester filter.
The cassette must be equipped with an electrically conductive 50 mm extension cowl.
The sampling time and rate are chosen to give a fiber density of between 100 to 1,300 fibers/mm2 on the filter. Recommended sampling rate 0.5 to 5.0 liters/minute L/min.
Recommended air volumes. Minimum is 25 L. Maximum is 400 L. Analytical procedure.
A portion of the sample filter is cleared and prepared for asbestos fiber counting by phase contrast microscopy, PCM, at 400x. Commercial manufacturers and products mentioned in this method are for descriptive use only and do not constitute endorsements by OSHA. Similar products from other sources can be substituted.
1. Introduction.
This method describes the collection of airborne asbestos fibers using calibrated sampling pumps with mixed cellulose ester, MC, filters and analysis by phase contrast microscopy, PCM. Some terms used are unique to this method and are defined below. Asbestos, a term for naturally occurring fibrous minerals. Asbestos includes chrysotile, crocidolite, amosite, cummingtonite, grunerite asbestos, tremolite asbestos, actinolite asbestos, anthophyllite asbestos, and any of these minerals that have been chemically treated and/or altered. The precise chemical formulation of each species will vary with the location from which it was mined. Nominal compositions are listed: chrysotile, crocidolite, amosite, tremolite, actinolite, anthophyllite. Asbestos fiber, a fiber of asbestos which meets the criteria specified below for a fiber. Aspect ratio, the ratio of the length of a fiber to its diameter, e.g. 3:1, 5:1 aspect ratios. Cleavage fragments, mineral particles formed by comminution of minerals, especially those characterized by parallel sides and a moderate aspect ratio, usually less than 20:1. Detection limit, the number of fibers necessary to be 95% certain that the result is greater than 0. Differential counting, the term applied to the practice of excluding certain kinds of fibers from the fiber count because they do not appear to be asbestos. Fiber, a particle that is 5 or longer, with a length-to-width ratio of 3:1 or longer. Field, the area within the graticule circle that is superimposed on the microscope image. Set, the samples which are taken, submitted to the laboratory, analyzed, and for which interim or final result reports are generated. Tremolite, anthophyllite, and actinolite, the non-asbestos form of these minerals which meet the definition of a fiber. It includes any of these minerals that have been chemically treated and/or altered. Walton-Beckett graticule, an eyepiece graticule specifically designed for asbestos fiber counting. It consists of a circle with a projected diameter of 100 plus or minus 2 area of about 0.00785 mm, 2, with a crosshair having tick marks at 3 intervals in one direction and 5 in the orthogonal direction. There are marks around the periphery of the circle to demonstrate the proper sizes and shapes of fibers. His design is reproduced in Figure 1. The disc is placed in one of the microscope eyepieces so that the design is superimposed on the field of view.
1.1 History. Early surveys to determine asbestos exposures were conducted using Impingeur counts of total dust with the counts expressed as million particles per cubic foot. The British Asbestos Research Council recommended filter membrane counting in 1969. In July 1969, the Bureau of Occupational Safety and Health published a filter membrane method for counting asbestos fibers in the United States. This method was refined by NIOSH and published as P and Chem 239. On May 29, 1971, OSHA specified filter membrane sampling with phase contrast counting for evaluation of asbestos exposures at work sites in the United States. The use of this technique was again required by OSHA in 1986. Phase contrast microscopy has continued to be the method of choice for the measurement of occupational exposure to asbestos. 1.2. Principle: air is drawn through a MCE filter to capture airborne asbestos fibers. A wedge-shaped portion of the filter is removed, placed on a glass microscope slide and made transparent. A measured area, field, is viewed by PCM. All the fibers meeting defined criteria for asbestos are counted and considered a measure of the airborne asbestos concentration. 1.3. Advantages and disadvantages. There are four main advantages of PCM over other methods. 1. The technique is specific for fibers. Phase contrast is a fiber counting technique which excludes non-fibrous particles from the analysis. 2. The technique is inexpensive and does not require specialized knowledge to carry out the analysis for total fiber counts. 3. The analysis is quick and can be performed on-site for rapid determination of air concentrations of asbestos fibers. 4. The technique has continuity with historical epidemiological studies so that estimates of expected disease can be inferred from long-term determinations of asbestos exposures. The main disadvantage of PCM is that it does not positively identify asbestos fibers. Other fibers which are not asbestos may be included in the count unless differential counting is performed. This requires a great deal of experience to adequately differentiate asbestos from non-asbestos fibers. Positive identification of asbestos must be performed by polarized light or electron microscopy techniques. A further disadvantage of PCM is that the smallest visible fibers are about 0.2 micrometers in diameter, while the finest asbestos fibers may be as small as 0.02 micrometers in diameter. For some exposures, substantially more fibers may be present than are actually counted. 1.4. Workplace exposure. Asbestos is used by the construction industry in such products as shingles, floor tiles, asbestos cement, roofing felts, insulation and acoustical products. Non-construction uses include brakes, clutch facings, paper, paints, plastics, and fabrics. One of the most significant exposures in the workplace is the removal and encapsulation of asbestos in schools, public buildings, and homes. Many workers have the potential to be exposed to asbestos during these operations. About 95% of the asbestos in commercial use in the United States is chrysotile. Crossatolite and amazite make up most of the remainder. Anthophthalite and tremolite or actinolite are likely to be encountered as contaminants in various industrial products. 1.5. Physical properties. Asbestos fiber possesses a high tensile strength along its axis, is chemically inert, non-combustible, and heat-resistant. It has a high electrical resistance and good sound-absorbing properties. It can be weaved into cables, fabrics or other textiles, and also matted into asbestos papers, felts, or mats. 2. Range and detection limit. 2.1. The ideal counting range on the filter is 100 to 1,300 fibers/m2. With a Walton-Beckett graticule, this range is equivalent to 0.8 to 10 fibers/field. Using NIOSH counting statistics, a count of 0.8 fibers/field would give an approximate coefficient of variation, CV, of 0.13. 2.2. The detection limit for this method is 4.0 fibers per 100 fields or 5.5 fibers/m2. This was determined using an equation to estimate the maximum CV possible at a specific concentration, 95% confidence, and a lower control limit of 0. The CV value was then used to determine a corresponding concentration from historical CV versus fiber relationships. As an example, lower control limit, 95% confidence, equals AC, 1.645 CV, AC. Where AC equals estimate of the airborne fiber concentration, fibers/cc, setting the lower control limit equals 0 and solving for CV. 0 equals AC, 1.645 CV, AC. CV equals 0.61. This value was compared with CV versus count curves. The count at which CV equals 0.61 for Lytle Bush counting statistics or for an OSHA Salt Lake Technical Center, OSHA SLTC, CV curve, see Appendix A for further information, was 4.4 fibers or 3.9 fibers per 100 fields, respectively. Although a lower detection limit of 4 fibers per 100 fields is supported by the OSHA SLTC data, both datasets support the 4.5 fibers per 100 fields value. 3. Method performance, precision and accuracy. Precision is dependent upon the total number of fibers counted and the uniformity of the fiber distribution on the filter. A general rule is to count at least 20 and not more than 100 fields. The count is discontinued when 100 fibers are counted, provided that 20 fields have already been counted. Counting more than 100 fibers results in only a small gain in precision. As the total count drops below 10 fibers, an accelerated loss of precision is noted. At this time, there is no known method to determine the absolute accuracy of the asbestos analysis. Results of samples prepared through the Proficiency Analytical Testing (PAT) program and analyzed by the OSHA SLTC showed no significant bias when compared to PAT reference values. The PAT samples were analyzed from 1987 to 1989, N equals 36, and the concentration range was from 120 to 1,300 fibers/m2. 4. Interferences. Fibrous substances, if present, may interfere with asbestos analysis. Some common fibers are fiberglass, anhydrite, plant fibers, perlite veins, gypsum, some synthetic fibers, membrane structures, sponge spicules, diatoms, microorganisms, wollastonite. The use of electron microscopy or optical tests such as polarized light and dispersion staining may be used to differentiate these materials from asbestos when necessary. 5. Sampling. 5.1. Equipment. 5.1.1. Sample assembly. The assembly is shown in Figure 3. Conductive filter holder consisting of a 25 mm diameter, 3-piece cassette having a 50 mm long electrically conductive extension cowl. Backup pad, 25 mm, cellulose. Membrane filter, mixed cellulose ester, MCE, 25 mm, plain, white, 0.4 to 1.2 micrometer pore size. Notes. A. Do not reuse cassettes. B. Fully conductive cassettes are required to reduce fiber loss to the sides of the cassette due to electrostatic attraction. C. Purchase filters which have been selected by the manufacturer for asbestos counting or analyze representative filters for fiber background before use. Discard the filter lot if more than 4 fibers/100 fields are found. D. To decrease the possibility of contamination, the sampling system, filter backup pad cassette, for asbestos is usually pre-assembled by the manufacturer. E. Other cassettes, such as the bell mouth, may be used within the limits of their validation. 5.1.2. Gel bands for sealing cassettes. 5.1.3. Sampling pump. Each pump must be a battery-operated, self-contained unit small enough to be placed on the monitored employee and not interfere with the work being performed. The pump must be capable of sampling at the collection rate for the required sampling time. 5.1.4. Flexible tubing, 6 mm bore. 5.1.5. Pump calibration. Stopwatch and bubble tube/burette or electronic meter. 5.2. Sampling procedure. 5.2.1. Seal the point where the base and cowl of each cassette meet with a gel band or tape. 5.2.2. Charge the pumps completely before beginning. 5.2.3. Connect each pump to a calibration cassette with an appropriate length of 6 mm bore plastic tubing. Do not use lure connectors, the type of cassette specified above has built-in adapters. 5.2.4. Select an appropriate flow rate for the situation being monitored. The sampling flow rate must be between 0.5 and 5.0 liters per minute for personal sampling and is commonly set between 1 and 2 liters per minute. Always choose a flow rate that will not produce overloaded filters. 5.2.5. Calibrate each sampling pump before and after sampling with a calibration cassette inline. Note, this calibration cassette should be from the same lot of cassettes used for sampling. Use a primary standard, e.g., bubble burette, to calibrate each pump. If possible, calibrate at the sampling site. Note, if sampling site calibration is not possible, environmental influences may affect the flow rate. The extent is dependent on the type of pump used. Consult with the pump manufacturer to determine dependence on environmental influences. If the pump is affected by temperature and pressure changes, correct the flow rate using the formula shown in the section Sampling Pump Flow Rate Corrections at the end of this appendix. 5.2.6. Connect each pump to the base of each sampling cassette with flexible tubing. Remove the end cap of each cassette and take each air sample open face. Assure that each sample cassette is held open side down in the employee's breathing zone during sampling. The distance from the nose/mouth of the employee to the cassette should be about 10 centimeters. Secure the cassette on the collar or lapel of the employee using spring clips or other similar devices. 5.2.7. A suggested minimum air volume when sampling to determine TWA compliance is 25 liters. For excursion limit, 30 minutes sampling time, evaluations, a minimum air volume of 48 liters is recommended. 5.2.8. The most significant problem when sampling for asbestos is overloading the filter with non-asbestos dust. Suggested maximum air sample volumes for specific environments are: asbestos removal operations, visible dust, 100. Asbestos removal operations, little dust, 240. Office environments 400 to 2400. Caution: do not overload the filter with dust. High levels of non-fibrous dust particles may obscure fibers on the filter and lower the count or make counting impossible. If more than about 25 to 30% of the field area is obscured with dust, the result may be biased low. Smaller air volumes may be necessary when there is excessive non-asbestos dust in the air. While sampling, observe the filter with a small flashlight. If there is a visible layer of dust on the filter, stop sampling, remove and seal the cassette, and replace with a new sampling assembly. The total dust loading should not exceed 1 mg. 5.2.9. Blank samples are used to determine if any contamination has occurred during sample handling. Prepare 2 blanks for the first 1 to 20 samples. For sets containing greater than 20 samples, prepare blanks as 10% of the samples. Handle blank samples in the same manner as air samples with one exception: do not draw any air through the blank samples. Open the blank cassette in the place where the sample cassettes are mounted on the employee. Hold it open for about 30 seconds. Close and seal the cassette appropriately. Store blanks for shipment with the sample cassettes. May 2, 2010. Immediately after sampling, close and seal each cassette with the base and plastic plugs. Do not touch or puncture the filter membrane as this will invalidate the analysis. May 2, 2011. Attach and secure a sample seal around each sample cassette in such a way as to assure that the end cap and base plugs cannot be removed without destroying the seal. Tape the ends of the seal together since the seal is not long enough to be wrapped end to end. Also wrap tape around the cassette at each joint to keep the seal secure. 5.3. Sample shipment. 5.3.1. Send the samples to the laboratory with paperwork requesting asbestos analysis. List any known fibrous interferences present during sampling on the paperwork. Also, note the workplace operations sampled. 5.3.2. Secure and handle the samples in such that they will not rattle during shipment nor be exposed to static electricity. Do not ship samples in expanded polystyrene peanuts, vermiculite, paper shreds, or Excelsior. Tape sample cassettes to sheet bubbles and place in a container that will cushion the samples in such a manner that they will not rattle. 5.3.3. To avoid the possibility of sample contamination, always ship bulk samples in separate mailing containers. 6. Analysis. 6.1. Safety precautions. 6.1.1. Acetone is extremely flammable and precautions must be taken not to ignite it. Avoid using large containers or quantities of acetone. Transfer the solvent in a ventilated laboratory hood. Do not use acetone near any open flame. For generation of acetone vapor, use a spark-free heat source. 6.1.2 Any asbestos spills should be cleaned up immediately to prevent dispersal of fibers. Prudence should be exercised to avoid contamination of laboratory facilities or exposure of personnel to asbestos. Asbestos spills should be cleaned up with wet methods and / or a high-efficiency particulate air (HEPA) filtered vacuum. Caution: do not use a vacuum without a HEPA filter, it will disperse fine asbestos fibers in the air. 6.2 Equipment 6.2.1 Phase contrast microscope with binocular or trinocular head. 6.2.2 Wide field or Hygenian 10x eyepieces. Note: the eyepiece containing the graticule must be a focusing eyepiece. Use a 40x phase objective with a numerical aperture of 0.65 to 0.75. 6.2.3 Koehler illumination, if possible, with green or blue filter. 6.2.4 Walton Beckett graticule, type G22 with 100 plus or minus 2 micrometers projected diameter. 6.2.5 Mechanical stage. A rotating mechanical stage is convenient for use with polarized light. 6.2.6 Phase telescope. 6.2.7 Stage micrometer with 0.01 mm subdivisions.
6.2.8 Phase shift test slide, Mark II, available from PTR Optics Limited, and also Macron. 6.2.9 Pre-cleaned glass slides, 25 mm x 75 mm.
One end can be frosted for convenience in writing sample numbers, etc., or paste on labels can be used.
June 2nd, 10. Cover glass number 1/2. June 2nd, 11. Scalpel, number 10, curved blade. June 2nd, 12. Fine-tipped forceps. June 2nd, 13. Aluminum block for clearing filter, see Appendix D and Figure 4. June 2nd, 14. Automatic adjustable pipette, 100 to 500 ul. June 2nd, 15. Micropipette, 5 ul. 6.3 Reagent, S. 6.3.1 Acetone, HPLC grade. 6.3.2 Triacetin, glycerol triacetate. 6.3.3 Lacquer or nail polish. 6.4 Standard preparation. A way to prepare standard asbestos samples of known concentration has not been developed. It is possible to prepare replicate samples of nearly equal concentration. This has been performed through the PAT program. These asbestos samples are distributed by the AIHA to participating laboratories. Since only about 1/4 of a 25 mm sample membrane is required for an asbestos count, any PAT sample can serve as a standard for replicate counting. 6.5 Sample mounting. Note: see safety precautions in section 6.1. Before proceeding, the objective is to produce samples with a smooth, non-grainy background in a medium with a refractive index of approximately 1.46. The technique below collapses the filter for easier focusing and produces permanent mounts which are useful for quality control and interlaboratory comparison. An aluminum block or similar device is required for sample preparation. 6.5.1 Heat the aluminum block to about 70 degrees Celsius. The hot block should not be used on any surface that can be damaged by either the heat or from exposure to acetone. 6.5.2 Ensure that the glass slides and cover glasses are free of dust and fibers. 6.5.3 Remove the top plug to prevent a vacuum when the cassette is opened. Clean the outside of the cassette if necessary. Cut the seal and/or tape on the cassette with a razor blade. Very carefully separate the base from the extension cowl, leaving the filter and backup pad in the base. 6.5.4 With a rocking motion, cut a triangular wedge from the filter using the scalpel.
This wedge should be 1/6 to 1/4 of the filter. Grasp the filter wedge with the forceps on the perimeter of the filter, which was clamped between the cassette pieces.
Do not touch the filter with your finger. Place the filter on the glass slide sample side up. Static electricity will usually keep the filter on the slide until it is cleared. 6.5.5. Place the tip of the micropipette containing about 200 ml acetone into the aluminum block. Insert the glass slide into the receiving slot in the aluminum block. Inject the acetone into the block with slow, steady pressure on the plunger while holding the pipette firmly in place.
Wait 3 to 5 seconds for the filter to clear, then remove the pipette and slide from the aluminum block.
6.5.6.
Immediately, less than 30 seconds, place 2.5 to 3.5 ml of triacetone on the filter. Note, waiting longer than 30 seconds will result in increased index of refraction and decreased contrast between the fibers and the preparation. This may also lead to separation of the cover slip from the slide.
6.5.7.
Lower a cover slip gently onto the filter at a slight angle to reduce the possibility of forming air bubbles. If more than 30 seconds have elapsed between acetone exposure and triacetone application, glue the edges of the cover slip to the slide with lacquer or nail polish.
6.5.8. If clearing is slow, warm the slide for 15 minutes on a hot plate having a surface temperature of about 50 degrees Celsius to hasten clearing. The top of the hot block can be used if the slide is not heated too long. 6.5.9. Counting may proceed immediately after clearing and mounting are completed. 6.6.1. Alignment. 1. Clean all optical surfaces. Even a small amount of dirt can significantly degrade the image. 2. Rough focus the objective on a sample. 3. Close down the field iris so that it is visible in the field of view. Focus the image of the iris with the condenser focus. Center the image of the iris in the field of view. 4. Install the phase telescope and focus on the phase rings. Critically center the rings. Misalignment of the rings results in astigmatism, which will degrade the image. 5. Place the phase shift test slide on the microscope stage and focus on the lines. The analyst must see line set 3 and should see at least parts of 4 and 5 but not see line set 6 or 6. A microscope/microscopist combination which does not pass this test may not be used. 6.6.2. Counting fibers. 1. Place the prepared sample slide on the mechanical stage of the microscope. Position the center of the wedge under the objective lens and focus upon the sample. 2. Start counting from one end of the wedge and progress along a radial line to the other end. Count in either direction from perimeter to wedge tip. Select fields randomly, without looking into the eyepieces, by slightly advancing the slide in one direction with the mechanical stage control. 3. Continually scan over a range of focal planes, generally the upper 10 to 15 of the filter surface, with the fine focus control during each field count. Spend at least 5 to 15 seconds per field. 4. Most samples will contain asbestos fibers with fiber diameters less than 1 Look carefully for faint fiber images. The small diameter fibers will be very hard to see. However, they are an important contribution to the total count. 5. Count only fibers equal to or longer than 5 Measure the length of curved fibers along the curve. 6. Count fibers which have a length to width ratio of 3 to 1 or greater. 7. Count all the fibers in at least 20 fields. Continue counting until either 100 fibers are counted or 100 fields have been viewed, whichever occurs first. Count all the fibers in the final field. 8. Fibers lying entirely within the boundary of the Walton-Beckett graticule field shall receive a count of 1. Fibers crossing the boundary once, having one end within the circle shall receive a count of 1/2. Do not count any fiber that crosses the graticule boundary more than once. Reject and do not count any other fibers even though they may be visible outside the graticule area. If a fiber touches the circle, it is considered to cross the line. 9. Count bundles of fibers as one fiber unless individual fibers can be clearly identified and each individual fiber is clearly not connected to another counted fiber. See Figure 1 for counting conventions.
10. Record the number of fibers in each field in a consistent way such that filter non-uniformity can be assessed.
11. Regularly check phase ring alignment.
12. When an agglomerate, mass of material, covers more than 25% of the field of view, reject the field and select another.
Do not include it in the number of fields counted. 13. Perform a blind recount of 1 in every 10 filter wedges, slides.
Relabel the slides using a person other than the original counter.
6.7. Fiber identification. As previously mentioned in Section 1.3, PCM does not provide positive confirmation of asbestos fibers. Alternate differential counting techniques should be used if discrimination is desirable.
Differential counting may include primary discrimination based on morphology, polarized light analysis of fibers, or modification of PCM data by scanning electron or transmission electron microscopy. A great deal of experience is required to routinely and correctly perform differential counting. It is discouraged unless it is legally necessary. Then, only if a fiber is obviously not asbestos should it be excluded from the count. Further discussion of this technique can be found in reference 8.10. If there is a question whether a fiber is asbestos or not, follow the rule. When in doubt, count. 6.8. Analytical Recommendations Quality Control System. 6.8.1. All individuals performing asbestos analysis must have taken the NIOSH course for sampling and evaluating airborne asbestos or an equivalent course. 6.8.2. Each laboratory engaged in asbestos counting shall set up a slide trading arrangement with at least 2 other laboratories in order to compare performance and eliminate inbreeding of error. The slide exchange occurs at least semi-annually. The round-robin results shall be posted where all analysts can view individual analysts' results. 6.8.3. Each laboratory engaged in asbestos counting shall participate in the Proficiency Analytical Testing Program, the Asbestos Analyst Registry or equivalent. 6.8.4. Each analyst shall select and count prepared slides from a slide bank. These are quality assurance counts. The slide bank shall be prepared using uniformly distributed samples taken from the workload. Fiber densities should cover the entire range routinely analyzed by the laboratory. These slides are counted blind by all counters to establish an original standard deviation. This historical distribution is compared with the quality assurance counts. A counter must have 95% of all quality control samples counted within 3 standard deviations of the historical mean. This count is then integrated into a new historical mean and standard deviation for the slide. The analyses done by the counters to establish the slide bank may be used for an interim quality control program if the data are treated in a proper statistical fashion. 7.1. Calculate the estimated airborne asbestos fiber concentration on the filter sample using the following formula, where AC equals airborne fiber concentration, FB equals total number of fibers greater than 5 uncounted, FL equals total number of fields counted on the filter, BFB equals total number of fibers greater than 5 uncounted in the blank, BFL equals total number of fields counted on the blank, ECA equals effective collecting area of filter, 385 mm, 2, nominal for a 25 mm filter. FR equals pump flow rate, L/min, MFA equals microscope count field area, mm2. This is 0.00785 mm2 for a Walton-Beckett graticule. T equals sample collection time, min, 1000 equals conversion of L to cc. Note, the collection area of a filter is seldom equal to 385 mm2. It is appropriate for laboratories to routinely monitor the exact diameter using an inside micrometer. The collection area is calculated according to Toth formula. Area equals pi, d/2, 2. 7.2. Shortcut calculation. Since a given analyst always has the same interpupillary distance, the number of fields per filter for a particular analyst will remain constant for a given size filter. The field size for that analyst is constant, i.e., the analyst is using an assigned microscope and is not changing the reticle. For example, if the exposed area of the filter is always 385 mm2, and the size of the field is always 0.00785 mm. 2. The number of fields per filter will always be 49,000. In addition, it is necessary to convert liters of air to cc. These three constants can then be combined such that ECA/1000 x MFA equals 49. The previous equation simplifies to 7.3. Recount calculations. As mentioned in step 13 of section 6.6.2, a blind recount of 10% of the slides is performed. In all cases, differences will be observed between the first and second counts of the same filter wedge. Most of these differences will be due to chance alone, that is, due to the random variability, precision, of the count method. Statistical recount criteria enables one to decide whether observed differences can be explained due to chance alone or are probably due to systematic differences between analysts, microscopes, or other biasing factors. The following recount criterion is for a pair of counts that estimate AC in fibers/cc. The criterion is given at the type I error level. That is, there is 5% maximum risk that we will reject a pair of counts for the reason that one might be biased, when the large observed difference is really due to chance. Reject a pair of counts if, where, AC1 equals lower estimated airborne fiber concentration, AC2 equals higher estimated airborne fiber concentration, AC average equals average of the two concentration estimates, CV, FB equals CV for the average of the two concentration estimates. If a pair of counts are rejected by this criterion, then recount the rest of the filters in the submitted set. Apply the test and reject any other pairs failing the test. Rejection shall include a memo to the industrial hygienist stating that the sample failed a statistical test for homogeneity and the true air concentration may be significantly different than the reported value. 7.4. Reporting results. Report results to the industrial hygienist as fibers/cc. Use two significant figures. If multiple analyses are performed on a sample, an average of the results is to be reported unless any of the results can be rejected for cause. 8. References. 8.1. Dreesen, W. C. et al., U.S. Public Health Service, A Study of Asbestosis in the Asbestos Textile Industry, Public Health Bulletin No. 241, U.S. Treasury Department, Washington, D.C., 1938. 8.2. Asbestos Research Council, The Measurement of Airborne Asbestos Dust by the Membrane Filter Method. Technical Note, Asbestos Research Council, Rochdale, Lancashire, Great Britain, 1969. 8.3. Bayer, S.G., Zumwalt, R.D., Brown, T.A. Equipment and Procedure for Mounting Millipore Filters and Counting Asbestos Fibers by Phase Contrast Microscopy, Bureau of Occupational Health, U.S. Department of Health, Education, and Welfare, Cincinnati, Ohio, 1969. 8.4. NIOSH Manual of Analytical Methods, 2nd edition, Volume 1, DHEW/NIOSH Pub. No. 77-157A. National Institute for Occupational Safety and Health, Cincinnati, Ohio, 1977. Pages 239 to 239 to 21. 8.5. Asbestos, Code of Federal Regulations 29 CFR 1910.1001. 1971. 8.6. Occupational exposure to asbestos, tremolite, anthophyllite, and actinolite. Final Rule, Federal Register 51:119, June 20, 1986. Pages 22,612 to 22,790. 8.7. Asbestos, tremolite, anthophyllite, and actinolite, Code of Federal Regulations 1910.1001. 1988, pages 711 to 752. 8.8. Criteria for a recommended standard occupational exposure to asbestos, DHEW/NIOSH Pub. No. HSM 72 to 10267, National Institute for Occupational Safety and Health, NIOSH, Cincinnati, Ohio, 1972. Pages 3-13-24. 8.9. Ladle, N.A. Bayer, S.G. Zumwalt, R.D. Bush, K.A. USPHS/NIOSH Membrane Filter Method for Evaluating Airborne Asbestos Fibers, DHEW/NIOSH Pub.
No.
79 to 127, National Institute for Occupational Safety and Health, Cincinnati, Ohio, 1979. 8.10, Dixon, W.C., Applications of Optical Microscopy in Analysis of Asbestos and Quartz, Analytical Techniques in Occupational Health Chemistry, edited by D.D. Dahlberg and A.W. Verstueft. Washington. DAC, American Chemical Society, ACS Symposium Series 120, 1980. Pages 13 to 41. Quality Control. The OSHA asbestos regulations require each laboratory to establish a quality control program. The following is presented as an example of how the OSHA SLTC constructed its internal CV curve as part of meeting this requirement. Data is from 395 samples collected during OSHA compliance inspections and analyzed from October 1980 through April 1986. Each sample was counted by 2 to 5 different counters independently of one another. The standard deviation and the CV statistic was calculated for each sample. This data was then plotted on a graph of CV versus fibers/mm2. A least squares regression was performed using the following equation. CV equals antilog 10 a log 10 x2 plus b log 10 x plus c, where x equals the number of fibers/mm2. Application of least squares gave a equals 0.182205, b equals 0.973343, c equals 0.327499. Using these values, the equation becomes CV equals antilog 10 0.182205 log 10 x 2 0.973343 log 10 x plus 0.327499. Sampling pump flow rate corrections. This correction is used if a difference greater than 5% in ambient temperature and/or pressure is noted between calibration and sampling sites and the pump does not compensate for the differences. Where Q act equals actual flow rate. Q cal equals calibrated flow rate. If a rotometer was used, the rotometer value P cal equals uncorrected air pressure at calibration. P act equals uncorrected air pressure at sampling site. T act equals temperature at sampling site. K T cal equals temperature at calibration. K Walton-Beckett graticule. When ordering the graticule for asbestos counting, specify the exact disc diameter needed to fit the ocular of the microscope and the diameter, m, of the circular counting area. Instructions for measuring the dimensions necessary are listed. 1. Insert any available graticule into the focusing eyepiece and focus so that the graticule lines are sharp and clear. 2. Align the microscope. 3. Place a stage micrometer on the microscope object stage and focus the microscope on the graduated lines. 4. Measure the magnified grid length, PL, using the stage micrometer. 5. Remove the graticule from the microscope and measure its actual grid length, AL, This can be accomplished by using a mechanical stage fitted with verniers, or a jeweler's loupe with a direct reading scale. 6. Let D equals 100 Calculate the circle diameter, DEC, for the Walton-Beckett graticule and specify the diameter when making a purchase. 7. Each eyepiece objective reticle combination on the microscope must be calibrated. Should any of the three be changed, by zoom adjustment, disassembly, replacement, etc., the combination must be recalibrated. Calibration may change if interpupillary distance is changed. Measure the field diameter, D, acceptable range, 100 plus or minus 2 with a stage micrometer upon receipt of the graticule from the manufacturer. Determine the field area, 2. Field area equals pi, D/2, 2. If D equals 100 equals 0.1 millimeters, then field area equals pi, 0.1 mm/2, 2, equals 0.00785 mm, 2. The graticule is available from Graticules Limited, Morley Road, Tunbridge TN 9 IRN, Kent, England, telephone 011-44-732-359061. Also available from PTR Optics Limited, 145, Newton Street, Waltham, Massachusetts, 02154, telephone 617-891-6000, or Macron Accessories and Components, 2506S.
Michigan Avenue, Chicago, Illinois 60616, phone 312-842-7100. The graticule is custom made for each microscope. Figure 1 Walton Beckett graticule with some explanatory fibers. Structure number 1 to 6, the count is 1, small fibers all contained within the circle. Structure number 7, the count is half, fiber crosses circle once. Structure number 8, the count is 0, fiber 2 short. Structure number 9, the count is 2, 2 crossing fibers. Structure number 10, the count is 0, fiber outside graticule. Structure number 11, the count is 0, fiber crosses graticule twice. Structure number 12, the count is half, although split, fiber only crosses once. 1926.1101 Appendix C. Reserved. 1926.1101 Appendix D. Medical questionnaires. Mandatory.
This mandatory appendix contains the medical questionnaires that must be administered to all employees who are exposed to asbestos above permissible exposure limit, and who will therefore be included in their employer's medical surveillance program. Part 1 of this appendix contains the medical questionnaire, which must be administered to all employees who are provided periodic medical examinations under the medical surveillance provisions of the standard in this section.
1926.1101 Appendix E. Classification of chest X-rays. Mandatory.
A. Chest X-rays shall be classified in accordance with the guidelines for the use of the ILO International Classification of Radiographs of Pneumoconioses, Revised Edition 2011, incorporated by reference, see Section 1926.6, and recorded on a classification form following the format of the CDC/NIOSH M. 2.8 form. As a minimum, the content within the bold lines of this form, items 1 through 4, shall be included.
This form is not to be submitted to NIOSH.
B. All X-rays shall be classified only by a B-reader, a board-eligible/certified radiologist, or an experienced physician with known expertise in pneumoconioses. C. Whenever classifying chest X-ray film, the physician shall have immediately available for reference a complete set of the ILO standard format radiographs provided for use with the guidelines for the use of the ILO International Classification of Radiographs of Pneumoconioses, Revised Edition 2011. D. Whenever classifying digitally acquired chest X-rays, the physician shall have immediately available for reference a complete set of ILO standard digital chest radiographic images provided for use with the guidelines for the use of the ILO International Classification of Radiographs of Pneumoconioses, Revised Edition 2011. Classification of digitally acquired chest X-rays shall be based on the viewing of images displayed as electronic copies and shall not be based on the viewing of hard copy printed transparencies of images. 1926.1101 Appendix F. Work practices and engineering controls for Class 1 asbestos operations.
Non-mandatory. This is a non-mandatory appendix to the asbestos standards for construction and for shipyards.
It describes criteria and procedures for erecting and using negative pressure enclosures for Class 1 asbestos work, when NPEs are used as an allowable control method to comply with paragraph G5I of this section.
Many small and variable details are involved in the erection of a negative pressure enclosure. OSHA and most participants in the rulemaking agreed that only the major, more performance-oriented criteria should be made mandatory.
These criteria are set out in paragraph G of this section. In addition, this appendix includes these mandatory specifications and procedures in its guidelines in order to make this appendix coherent and helpful. The mandatory nature of the criteria which appear in the regulatory text is not changed because they are included in this non-mandatory appendix.
Similarly, the additional criteria and procedures included as guidelines in the appendix do not become mandatory because mandatory criteria are also included in these comprehensive guidelines. In addition, none of the criteria, both mandatory and recommended, are meant to specify or imply the need for use of patented or licensed methods or equipment. Recommended specifications included in this attachment should not discourage the use of creative alternatives which can be shown to reliably achieve the objectives of negative pressure enclosures. Requirements included in this appendix cover general provisions to be followed in all asbestos jobs, provisions which must be followed for all Class 1 asbestos jobs, and provisions governing the construction and testing of negative pressure enclosures.
The first category includes the requirement for use of wet methods, HEPA vacuums, and immediate bagging of waste. Class 1 work must conform to the following provisions:
oversight by competent person, use of critical barriers over all openings to work area, isolation of HVAC systems,
use of impermeable drop cloths and coverage of all objects within regulated areas.
In addition, more specific requirements for NPEs include
maintenance of -0.02 inches water gauge within enclosure,
manometric measurements,
air movement away from employees performing removal work,
smoke testing or equivalent for detection of leaks and air direction,
deactivation of electrical circuits,
if not provided with ground fault circuit interrupters. Ground fault circuit interrupters.
The standard requires that an exposure assessment be conducted before the asbestos job is begun. Section
1926.1101 F1.
Information needed for that assessment includes data relating to prior similar jobs, as applied to the specific variables of the current job. The information needed to conduct the assessment will be useful in planning the project and in complying with any reporting requirements under this standard. When significant changes are being made to a control system listed in the standard, see also those of USEPA 40 CFR 61, Subpart M. Thus, although the standard does not explicitly require the preparation of a written asbestos removal plan, the usual constituents of such a plan, i.e., a description of the enclosure, the equipment, and the procedures to be used throughout the project, must be determined before the enclosure can be erected.
The following information should be included in the planning of the system: a physical description of the work area,
a description of the approximate amount of material to be removed,
a schedule for turning off and sealing existing ventilation systems, personnel hygiene procedures, a description of personal protective equipment and clothing to be worn by employees,
a description of the local exhaust ventilation systems to be used and how they are tested, a description of work practices to be observed by employees,
an air monitoring plan,
a description of the method to be used to transport waste material,
and the location of the dump site. Materials and equipment necessary for asbestos removal.
Although individual asbestos removal projects vary in terms of the equipment required to accomplish the removal of the materials, some equipment and materials are common to most asbestos removal operations.
Plastic sheeting used to protect horizontal surfaces, seal HVAC openings, or to seal vertical openings and ceilings should have a minimum thickness of 6 mils.
Tape or other adhesive used to attach plastic sheeting should be of sufficient adhesive strength to support the weight of the material plus all stresses encountered during the entire duration of the project without becoming detached from the surface. Other equipment and materials which should be available at the beginning of each project are:
HEPA filtered vacuum is essential for cleaning the work area after the asbestos has been removed.
It should have a long hose capable of reaching out of the way places, such as areas above ceiling tiles, behind pipes, etc. Portable air ventilation systems installed to provide the negative air pressure and air removal from the enclosure must be equipped with a HEPA filter. The number and capacity of units required to ventilate an enclosure depend on the size of the area to be ventilated. The filters for these systems should be designed in such a manner that they can be replaced when the airflow volume is reduced by the buildup of dust in the filtration material. Pressure monitoring devices with alarms and strip chart recorders attached to each system to indicate the pressure differential and the loss due to dust buildup on the filter are recommended. Water sprayers should be used to keep the asbestos material as saturated as possible during removal. The sprayers will provide a fine mist that minimizes the impact of the spray on the material. Water used to saturate the asbestos-containing material can be amended by adding at least 15 milliliters, 1/4 ounce, of wetting agent in 1 liter, 1 pint, of water.
An example of a wetting agent is a 50/50 mixture of polyoxyethylene ether and polyoxyethylene polyglycol ester.
Backup power supplies are recommended, especially for ventilation systems. Shower and bath water should be with mixed hot and cold water faucets. Water that has been used to clean personnel or equipment should either be filtered or be collected and discarded as asbestos waste. Soap and shampoo should be provided to aid in removing dust from the worker's skin and hair. See paragraphs H and I of this section for appropriate respiratory protection and protective clothing. See paragraph K of this section for required signs and labels.
Preparing the work area. Disabling HVAC systems.
The power to the heating, ventilation, and air conditioning systems that service the restricted area must be deactivated and locked off. All ducts, grills, access ports, windows, and vents must be sealed off with 2 layers of plastic to prevent entrainment of contaminated air. Operating HVAC systems in the restricted area. If components of a HVAC system located in the restricted area are connected to a system that will service another zone during the project, the portion of the duct in the restricted area must be sealed and pressurized. Necessary precautions include caulking the duct joints, covering all cracks and openings with 2 layers of sheeting, and pressurizing the duct throughout the duration of the project by restricting the return airflow. The power to the fan supplying the positive pressure should be locked on to prevent pressure loss. Sealing elevators. If an elevator shaft is located in the restricted area, it should be either shut down or isolated by sealing with 2 layers of plastic sheeting. The sheeting should provide enough slack to accommodate the pressure changes in the shaft without breaking the airtight seal. Removing mobile objects. All movable objects should be cleaned and removed from the work area before an enclosure is constructed unless moving the objects creates a hazard. Mobile objects will be assumed to be contaminated and should be either cleaned with amended water and a HEPA vacuum and then removed from the area, or wrapped and then disposed of as hazardous waste. Cleaning and sealing surfaces. After cleaning with water and a HEPA vacuum, surfaces of stationary objects should be covered with 2 layers of plastic sheeting. The sheeting should be secured with duct tape or an equivalent method to provide a tight seal around the object. Bagging waste. In addition to the requirement for immediate bagging of waste for disposal, it is further recommended that the waste material be double bagged and sealed in plastic bags designed for asbestos disposal. The bags should be stored in a waste storage area that can be controlled by the workers conducting the removal. Filters removed from air handling units and rubbish removed from the area are to be bagged and handled as hazardous waste. Constructing the enclosure. The enclosure should be constructed to provide an airtight seal around ducts and openings into existing ventilation systems and around penetrations for electrical conduits, telephone wires, water lines, drain pipes, etc. Enclosures should be both airtight and watertight except for those openings designed to provide entry and/or airflow control. Size. An enclosure should be the minimum volume to encompass all of the working surfaces yet allow unencumbered movement by the workers, provide unrestricted airflow past the workers, and ensure walking surfaces can be kept free of tripping hazards. Shape. The enclosure may be any shape that optimizes the flow of ventilation air past the workers. Structural integrity. The walls, ceilings, and floors must be supported in such a manner that portions of the enclosure will not fall down during normal use. Openings. It is not necessary that the structure be airtight. Openings may be designed to direct airflow. Such openings should be located at a distance from active removal operations. They should be designed to draw air into the enclosure under all anticipated circumstances. In the event that negative pressure is lost, they should be fitted with either HEPA filters to trap dust or automatic trapdoors that prevent dust from escaping the enclosure. Openings for exits should be controlled by an airlock or a vestibule. Barrier supports. Frames should be constructed to support all unsupported spans of sheeting. Sheeting. Walls, barriers, ceilings, and floors should be lined with 2 layers of plastic sheeting having a thickness of at least 6 mm. Seams. Seams in the sheeting material should be minimized to reduce the possibilities of accidental rips and tears in the adhesive or connections. All seams in the sheeting should overlap, be staggered, and not be located at corners or wall-to-floor joints. Areas within an enclosure. Each enclosure consists of a work area, a decontamination area, and waste storage area. The work area where the asbestos removal operations occur should be separated from both the waste storage area and the contamination control area by physical curtains, doors, and/or airflow patterns that force any airborne contamination back into the work area. See paragraph J of this section for requirements for hygiene facilities. During egress from the work area, each worker should step into the equipment room, clean tools and equipment, and remove gross contamination from clothing by wet cleaning and HEPA vacuuming. Before entering the shower area, foot coverings, head coverings, hand coverings, and coveralls are removed and placed in impervious bags for disposal or cleaning. Airline connections from airline respirators with HEPA disconnects and power cables from powered air purifying respirators, PAPRs, will be disconnected just prior to entering the shower room.
Establishing negative pressure within the enclosure.
Negative pressure air is to be drawn into the enclosure under all anticipated conditions and exhausted through a HEPA filter for 24 hours a day during the entire duration of the project. Airflow tests. Airflow patterns will be checked before removal operations begin, at least once per operating shift and any time there is a question regarding the integrity of the enclosure. The primary test for airflow is to trace air currents with smoke tubes or other visual methods. Flow checks are made at each opening and at each doorway to demonstrate that air is being drawn into the enclosure and at each worker's position to show that air is being drawn away from the breathing zone. Monitoring pressure within the enclosure. After the initial airflow patterns have been checked, the static pressure must be monitored within the enclosure. Monitoring may be made using manometers, pressure gauges, or combinations of these devices. It is recommended that they be attached to alarms and strip chart recorders at points identified by the design engineer. Corrective actions. If the manometers or pressure gauges demonstrate a reduction in pressure differential below the required level, work should cease and the reason for the change investigated and appropriate changes made. The airflow patterns should be retested before work begins again. Pressure differential. The design parameters for static pressure differentials between the inside and outside of enclosures typically range from 0.02 to 0.10 inches of water gauge, depending on conditions. All zones inside the enclosure must have less pressure than the ambient pressure outside of the enclosure, minus 0.02 inches water gauge differential. Design specifications for the differential vary according to the size, configuration, and shape of the enclosure as well as ambient and mechanical air pressure conditions around the enclosure. Airflow patterns. The flow of air past each worker shall be enhanced by positioning the intakes and exhaust ports to remove contaminated air from the worker's breathing zone, by positioning HEPA vacuum cleaners to draw air from the worker's breathing zone, by forcing relatively uncontaminated air past the worker toward an exhaust port, or by using a combination of methods to reduce the worker's exposure. Air handling unit exhaust. The exhaust plume from air handling units should be located away from adjacent personnel and intakes for HVAC systems. Airflow volume. The airflow volume, cubic meters per minute, exhausted, removed, from the workplace must exceed the amount of makeup air supplied to the enclosure. The rate of air exhausted from the enclosure should be designed to maintain a negative pressure in the enclosure and air movement past each worker. The volume of airflow removed from the enclosure should replace the volume of the container at every 5 to 15 minutes. Airflow volume will need to be relatively high for large enclosures, enclosures with awkward shapes, enclosures with multiple openings, and operations employing several workers in the enclosure. Airflow velocity. At each opening, the airflow velocity must visibly drag air into the enclosure. The velocity of airflow within the enclosure must be adequate to remove airborne contamination from each worker's breathing zone without disturbing the asbestos-containing material on surfaces. Airlocks. Airlocks are mechanisms on doors and curtains that control the airflow patterns in the doorways. If airflow occurs, the patterns through doorways must be such that the air flows toward the inside of the enclosure. Sometimes vestibules, double doors, or double curtains are used to prevent air movement through the doorways. To use a vestibule, a worker enters a chamber by opening the door or curtain and then closing the entry before opening the exit door or curtain. Airlock should be located between the equipment room and shower room, between the shower room and the clean room, and between the waste storage area and the outside of the enclosure. The airflow between adjacent rooms must be checked using smoke tubes or other visual tests to ensure the flow patterns draw air toward the work area without producing eddies. Monitoring for airborne concentrations. In addition to the breathing zone samples taken as outlined in paragraph F of this section, samples of air should be taken to demonstrate the integrity of the enclosure, the cleanliness of the clean room and shower area, and the effectiveness of the HEPA filter. If the clean room is shown to be contaminated, the room must be relocated to an uncontaminated area. Samples taken near the exhaust of portable ventilation systems must be done with care. General work practices. Preventing dust dispersion is the primary means of controlling the spread of asbestos within the enclosure. Whenever practical, the point of removal should be isolated, enclosed, covered, or shielded from the workers in the area. Waste asbestos-containing materials must be bagged during or immediately after removal. The material must remain saturated until the waste container is sealed.
Waste material with sharp points or corners must be placed in hard airtight containers rather than bags. Whenever possible, large components should be sealed in plastic sheeting and removed intact. Bags or containers of waste will be moved to the waste holding area, washed, and wrapped in a bag with the appropriate labels. Cleaning the work area. Surfaces within the work area should be kept free of visible dust and debris to the extent feasible. Whenever visible dust appears on surfaces, the surfaces within the enclosure must be cleaned by wiping with a wet sponge, brush, or cloth and then vacuumed with a HEPA vacuum. All surfaces within the enclosure should be cleaned before the exhaust ventilation system is deactivated and the enclosure is disassembled. An approved encapsulant may be sprayed onto areas after the visible dust has been removed. 1926.1101 Appendix G. Reserved. 1926.1101 Appendix H. Substance technical information for asbestos. Non-mandatory. I. Substance identification. A. Substance, asbestos, is the name of a class of magnesium silicate minerals that occur in fibrous form. Minerals that are included in this group are chrysotile, crocidolite, amosite, anthophyllite asbestos, tremolite asbestos, and actinolite asbestos. B. Asbestos is and was used in the manufacture of heat-resistant clothing, automotive brake and clutch linings, and a variety of building materials including floor tiles, roofing felts, ceiling tiles, asbestos cement pipe and sheet, and fire-resistant drywall. Asbestos is also present in pipe and boiler insulation materials and in sprayed-on materials located on beams, in crawlspaces, and between walls. C. The potential for an asbestos-containing product to release breathable fibers depends largely on its degree of friability. Friable means that the material can be crumbled with hand pressure and is therefore likely to emit fibers. The fibrous fluffy sprayed-on materials used for fireproofing, insulation, or soundproofing are considered to be friable, and they readily release airborne fibers if disturbed. Materials such as vinyl asbestos floor tile or roofing felt are considered non-friable if intact and generally do not emit airborne fibers unless subjected to sanding, sawing, and other aggressive operations. Asbestos cement pipe or sheet can emit airborne fibers if the materials are cut or sawed, or if they are broken. D. Permissible exposure. Exposure to airborne asbestos fibers may not exceed 0.1 fibers per cubic centimeter of air, 0.1 f/cc, averaged over the 8-hour workday, and 1 fiber per cubic centimeter of air, 1.0 f/cc, averaged over a 30-minute work period. 2. Health hazard data. A. Asbestos can cause disabling respiratory disease and various types of cancers if the fibers are inhaled. Inhaling or ingesting fibers from contaminated clothing or skin can also result in these diseases. The symptoms of these diseases generally do not appear for 20 or more years after initial exposure. B. Exposure to asbestos has been shown to cause lung cancer, mesothelioma, and cancer of the stomach and colon. Mesothelioma is a rare cancer of the thin membrane lining of the chest and abdomen. Symptoms of mesothelioma include shortness of breath, pain in the walls of the chest, and/or abdominal pain. 3. Respirators and protective clothing. A. Respirators. You are required to wear a respirator when performing tasks that result in asbestos exposure that exceeds the permissible exposure limit, PL, of 0.1 f/cc and when performing certain designated operations. Air purifying respirators equipped with a high-efficiency particulate air (HEPA) filter can be used where airborne asbestos fiber concentrations do not exceed 1.0 f/cc. Otherwise, more protective respirators such as air-supplied, positive pressure, full face-piece respirators must be used. Disposable respirators or dust masks are not permitted to be used for asbestos work. For effective protection, respirators must fit your face and head snugly. Your employer is required to conduct a fit test when you are first assigned a respirator and every 6 months thereafter. Respirators should not be loosened or removed in work situations where their use is required. B. Protective clothing. You are required to wear protective clothing in work areas where asbestos fiber concentrations exceed the permissible exposure limit, PL, of 0.1 f/cc. 4. Disposal procedures and cleanup. A. Wastes that are generated by processes where asbestos is present include 1. Empty asbestos shipping containers. 2. Process wastes such as cuttings, trimmings, or reject materials. 3. Housekeeping waste from wet sweeping or HEPA vacuuming. 4. Asbestos fireproofing or insulating material that is removed from buildings. 5. Asbestos-containing building products removed during building renovation or demolition. 6. Contaminated disposable protective clothing. B.
Empty shipping bags can be flattened under exhaust hoods and packed into airtight containers for disposal. Empty shipping drums are difficult to clean and should be sealed. C. Vacuum bags or disposable paper filters should not be cleaned, but should be sprayed with a fine water mist and placed into a labeled waste container. D. Process waste and housekeeping waste should be wetted with water or a mixture of water and surfactant prior to packaging in disposable containers. E. Asbestos-containing material that is removed from buildings must be disposed of in leak-tight 6mm plastic bags, plastic-lined cardboard containers, or plastic-lined metal containers. These wastes, which are removed while wet, should be sealed in containers before they dry out to minimize the release of asbestos fibers during handling. V. Access to information. A. Each year, your employer is required to inform you of the information contained in this standard and appendices for asbestos. In addition, your employer must instruct you in the proper work practices for handling asbestos-containing materials and the correct use of protective equipment. B. Your employer is required to determine whether you are being exposed to asbestos. Your employer must treat exposure to thermal system insulation and sprayed-on and troweled-on surfacing material as asbestos exposure, unless results of laboratory analysis show that the material does not contain asbestos. You or your representative has the right to observe employee measurements and to record the results obtained. Your employer is required to inform you of your exposure, and, if you are exposed above the permissible exposure limit, he or she is required to inform you of the actions that are being taken to reduce your exposure to within the permissible limit. C. Your employer is required to keep records of your exposures and medical examinations. These exposure records must be kept for at least 30 years. Medical records must be kept for the period of your employment plus 30 years. D. Your employer is required to release your exposure and medical records to your physician or designated representative upon your written request. 1926.1101 Appendix I. Medical Surveillance Guidelines for Asbestos. Non-mandatory. Appendix I to Section 1926.1101 Medical Surveillance Guidelines for Asbestos. Non-mandatory. I. Route of entry. Inhalation, ingestion. 2. Toxicology. Clinical evidence of the adverse effects associated with exposure to asbestos is present in the form of several well-conducted epidemiological studies of occupationally exposed workers, family contacts of workers, and persons living near asbestos mines. These studies have shown a definite association between exposure to asbestos and an increased incidence of lung cancer, pleural and peritoneal mesothelioma, gastrointestinal cancer, and asbestosis. The latter is a disabling fibrotic lung disease that is caused only by exposure to asbestos. Exposure to asbestos has also been associated with an increased incidence of esophageal, kidney, laryngeal, pharyngeal, and buccal cavity cancers. As with other known chronic occupational diseases, disease associated with asbestos generally appears about 20 years following the first occurrence of exposure. There are no known acute effects associated with exposure to asbestos. Epidemiological studies indicate that the risk of lung cancer among exposed workers who smoke cigarettes is greatly increased over the risk of lung cancer among non-exposed smokers or exposed non-smokers. These studies suggest that cessation of smoking will reduce the risk of lung cancer for a person exposed to asbestos but will not reduce it to the same level of risk as that existing for an exposed worker who has never smoked. 3. Signs and symptoms of exposure-related disease. The signs and symptoms of lung cancer or gastrointestinal cancer induced by exposure to asbestos are not unique, except that a chest X-ray of an exposed patient with lung cancer may show pleural plaques, pleural calcification, or pleural fibrosis, and may also show asbestosis, i.e., small irregular parenchymal opacities. Symptoms characteristic of mesothelioma include shortness of breath, pain in the chest, or abdominal pain. Mesothelioma has a much longer average latency period compared with lung cancer, 40 years versus 15 to 20 years, and mesothelioma is therefore more likely to be found among workers who were first exposed to asbestos at an early age. Mesothelioma is a fatal disease.
Asbestosis is pulmonary fibrosis caused by the accumulation of asbestos fibers in the lungs.
Symptoms include shortness of breath, coughing, fatigue, and vague feelings of sickness. When the fibrosis worsens, shortness of breath occurs even at rest. The diagnosis of asbestosis is most commonly based on a history of exposure to asbestos, the presence of characteristic radiologic abnormalities, and inspiratory crackles, rales, and other clinical features of fibrosing lung disease. Pleural plaques and thickening may be observed on chest X-rays. Asbestosis is often a progressive disease even in the absence of continued exposure, although this appears to be a highly individualized characteristic. In severe cases, death may be caused by respiratory or cardiac failure. 4. Surveillance and preventive considerations. As noted above, exposure to asbestos has been linked to an increased risk of lung cancer, mesothelioma, gastrointestinal cancer, and asbestosis among occupationally exposed workers. Adequate screening tests to determine an employee's potential for developing serious chronic diseases, such as a cancer, from exposure to asbestos do not presently exist. However, some tests, particularly chest X-rays and pulmonary function tests, may indicate that an employee has been overexposed to asbestos, increasing his or her risk of developing exposure-related chronic diseases. It is important for the physician to become familiar with the operating conditions in which occupational exposure to asbestos is likely to occur. This is particularly important in evaluating medical and work histories and in conducting physical examinations. When an active employee has been identified as having been overexposed to asbestos, measures taken by the employer to eliminate or mitigate further exposure should also lower the risk of serious long-term consequences. The employer is required to institute a medical surveillance program for all employees who are or will be exposed to asbestos at or above the permissible exposure limit, 0.1 fiber per cubic centimeter of air. All examinations and procedures must be performed by or under the supervision of a licensed physician, at a reasonable time and place, and at no cost to the employee. Although broad latitude is given to the physician in prescribing specific tests to be included in the medical surveillance program, OSHA requires inclusion of the following elements in the routine examination. Medical and work histories with special emphasis directed to symptoms of the respiratory system, cardiovascular system, and digestive tract. 2. Completion of the respiratory disease questionnaire contained in Appendix D. 3. A physical examination including a chest X-ray and pulmonary function test that includes measurement of the employee's forced vital capacity, FVC, and forced expiratory volume at 1 second, FEV1. 4. Any laboratory or other test that the examining physician deems by sound medical practice to be necessary. The employer is required to make the prescribed tests available at least annually to those employees covered, more often than specified if recommended by the examining physician, and upon termination of employment. The employer is required to provide the physician with the following information: a copy of this standard and appendices, a description of the employee's duties as they relate to asbestos exposure, the employee's representative level of exposure to asbestos, a description of any personal protective and respiratory equipment used, and information from previous medical examinations of the affected employee that is not otherwise available to the physician. Making this information available to the physician will aid in the evaluation of the employee's health in relation to assigned duties and fitness to wear personal protective equipment if required. The employer is required to obtain a written opinion from the examining physician containing the results of the medical examination, the physician's opinion as to whether the employee has any detected medical conditions that would place the employee at an increased risk of exposure-related disease, any recommended limitations on the employee or on the use of personal protective equipment, and a statement that the employee has been informed by the physician of the results of the medical examination and of any medical conditions related to asbestos exposure that require further explanation or treatment. This written opinion must not reveal specific findings or diagnoses unrelated to exposure to asbestos, and a copy of the opinion must be provided to the affected employee. 1926.1101 Appendix J. Smoking Cessation Program Information for Asbestos. Non-mandatory. Appendix J to Section 1926.1101. Smoking Cessation Program Information for Asbestos. Non-mandatory. The following organizations provide smoking cessation information. 1. The National Cancer Institute operates a toll-free cancer information service, CIS, with trained personnel to help you. Call 1-800-FOR-CANCER* to reach the CIS office serving your area, or write Office of Cancer Communications, National Cancer Institute, National Institutes of Health, Building 31, Room 10A24, Bethesda, Maryland, 20892. 2. American Cancer Society, 3340 Peachtree Road, NE, Atlanta, Georgia, 30026, 404, 320-3333. The American Cancer Society, ACS, is a voluntary organization composed of 58 divisions and 3,100 local units. Through the Great American Smokeout in November, the annual Cancer Crusade in April, and numerous educational materials, ACS helps people learn about the health hazards of smoking and become successful ex-smokers. 3. American Heart Association, 7320 Greenville Avenue, Dallas, Texas, 75231-214, 750-5300. The American Heart Association, AHA, is a voluntary organization with 130,000 members, physicians, scientists, and laypersons, in 55 state and regional groups. AHA produces a variety of publications and audiovisual materials about the effects of smoking on the heart. AHA also has developed a guidebook for incorporating a weight control component into smoking cessation programs. 4. American Lung Association, 1740 Broadway, New York, 10019, 212, 245-8000. A voluntary organization of 7,500 members, physicians, nurses, and laypersons, the American Lung Association, ALA, conducts numerous public information programs about the health effects of smoking. ALA has 59 state and 85 local units. The organization actively supports legislation and information campaigns for non-smokers' rights and provides help for smokers who want to quit, for example, through Freedom from Smoking, a self-help smoking cessation program. 5. Office on Smoking and Health, U.S. Department of Health and Human Services, 5600 Fishers Lane, Park Building, Room 110, Rockville, Maryland, 20857. The Office on Smoking and Health, OSHA, is the Department of Health and Human Services lead agency in smoking control. OSHA has sponsored distribution of publications on smoking-related topics, such as free flyers on relapse after initial quitting, helping a friend or family member quit smoking, the health hazards of smoking, and the effects of parental smoking on teenagers. In Hawaii, on Oahu, call 524-1234. Call collect from neighboring islands. Spanish-speaking staff members are available during daytime hours to callers from the following areas: California, Florida, Georgia, Illinois, New Jersey, area code 201, New York, and Texas. Consult your local telephone directory for listings of local chapters. 1926.1101 Appendix K. Polarized light microscopy of asbestos. Non-mandatory. Appendix K to Section 1926.1101 Polarized light microscopy of asbestos. Non-mandatory. Method number ID 191. Matrix, bulk, collection procedure. Collect approximately 1 to 2 grams of each type of material and place into separate 20 ml scintillation vials. Analytical procedure. A portion of each separate phase is analyzed by gross examination, phase polar examination, and central stop dispersion microscopy. Commercial manufacturers and products mentioned in this method are for descriptive use only and do not constitute endorsements by OSHA. Similar products from other sources may be substituted. 1. Introduction. This method describes the collection and analysis of asbestos bulk materials by light microscopy techniques, including phase polar illumination and central stop dispersion microscopy. Some terms unique to asbestos analysis are defined below. Amphibole. A family of minerals whose crystals are formed by long, thin units which have 2 thin ribbons of double-chain silicate with a brucite ribbon in between. The shape of each unit is similar to an I-beam. Minerals important in asbestos analysis include cummingtonite grunerite, crocidolite, tremolite actinolite, and anthophyllite. Asbestos, a term for naturally occurring fibrous minerals. Asbestos includes chrysotile, cummingtonite grunerite asbestos, amosite, anthophyllite asbestos, tremolite asbestos, crocidolite, actinolite asbestos, and any of these minerals which have been chemically treated or altered. The precise chemical formulation of each species varies with the location from which it was mined.
Nominal compositions are listed. Asbestos fiber.
A fiber of asbestos meeting the criteria for a fiber. See section 3.5 of this appendix, aspect ratio. The ratio of the length of a fiber to its diameter, usually defined as length, width, e.g.
3:1. Brucite,
a sheet mineral with the composition MgOH2.
Central stop dispersion staining, microscope.
This is a dark field microscope technique that images particles using only light refracted by the particle, excluding light that travels through the particle unrefracted. This is usually accomplished with a Macron objective or other arrangement which places a circular stop with apparent aperture equal to the objective aperture in the backfocal plane of the microscope.
Cleavage fragments.
Mineral particles formed by the combination of minerals, especially those characterized by relatively parallel sides and moderate aspect ratio.
Differential counting.
The term applied to the practice of excluding certain kinds of fibers from a phase contrast asbestos count because they are not asbestos.
Fiber.
A particle longer than or equal to 5 m with a length to width ratio greater than or equal to 3:1.
This may include cleavage fragments. See section 3.5 of this appendix. Phase contrast.
Contrast obtained in the microscope by causing light scattered by small particles to destructively interfere with unscattered light, thereby enhancing the visibility of very small particles and particles with very low intrinsic contrast.
Phase contrast microscope.
A microscope configured with a phase mask pair to create phase contrast. The technique which uses this is called phase contrast microscopy, PCM.
Phase polar analysis.
This is the use of polarized light in a phase contrast microscope. It is used to see the same size fibers that are visible in air filter analysis. Although fibers finer than 1 m are visible, analysis of these is inferred from analysis of larger bundles that are usually present.
Phase polar microscope. The phase polar microscope is a phase contrast microscope which has an analyzer, a polarizer, a first-order red plate and a rotating phase condenser all in place so that the polarized light image is enhanced by phase contrast. Sealing encapsulant. This is a product which can be applied, preferably by spraying, onto an asbestos surface which will seal the surface so that fibers cannot be released. Serpentine.
A mineral family consisting of minerals with the general composition Mg3, C2O5, OH, for having the magnesium in brucite layer over a silicate layer.
Minerals important in asbestos analysis included in this family are chrysotile, lizardite, antigorite. 1.1.
History. Light microscopy has been used for well over 100 years for the determination of mineral species. This analysis is carried out using specialized polarizing microscopes as well as bright field microscopes.
The identification of minerals is an ongoing process with many new minerals described each year.
The first recorded use of asbestos was in Finland about 2500 BC, where the material was used in the mud wattle for the wooden huts the people lived in as well as strengthening for pottery. Adverse health aspects of the mineral were noted nearly 2,000 years ago when Pliny the Younger wrote about the poor health of slaves in the asbestos mines. Although known to be injurious for centuries, the first modern references to its toxicity were by the British Labour Inspectorate when it banned asbestos dust from the workplace in 1898.
Asbestosis cases were described in the literature after the turn of the century.
Cancer was first suspected in the mid-1930s and a causal link to mesothelioma was made in 1965. Because of the public concern for worker and public safety with the use of this material, several different types of analysis were applied to the determination of asbestos content. Light microscopy requires a great deal of experience and craft. Attempts were made to apply less subjective methods to the analysis. X-ray diffraction was partially successful in determining the mineral types but was unable to separate out the fibrous portions from the non-fibrous portions. Also, the minimum detection limit for asbestos analysis by X-ray diffraction, XRD, is about 1%. Differential thermal analysis, DTA, was no more successful. These provide useful corroborating information when the presence of asbestos has been shown by microscopy. However, neither can determine the difference between fibrous and non-fibrous minerals when both habits are present. The same is true of infrared absorption, IR. When electron microscopy was applied to asbestos analysis, hundreds of fibers were discovered present too small to be visible in any light microscope. There are two different types of electron microscope used for asbestos analysis: scanning electron microscope, SEM, and transmission electron microscope, TM. Scanning electron microscopy is useful in identifying minerals. The SEM can provide two of the three pieces of information required to identify fibers by electron microscopy: morphology and chemistry. The third is structure as determined by selected area electron diffraction (SED), which is performed in the TEM. Although the resolution of the SEM is sufficient for very fine fibers to be seen, accuracy of chemical analysis that can be performed on the fibers varies with fiber diameter in fibers of less than 0.2 m diameter. The TEM is a powerful tool to identify fibers too small to be resolved by light microscopy and should be used in conjunction with this method when necessary. The TEM can provide all three pieces of information required for fiber identification. Most fibers thicker than 1 m can adequately be defined in the light microscope. The light microscope remains as the best instrument for the determination of mineral type. This is because the minerals under investigation were first described analytically with the light microscope. It is inexpensive and gives positive identification for most samples analyzed. Further, when optical techniques are inadequate, there is ample indication that alternative techniques should be used for complete identification of the sample. 1.2. Principal minerals consist of atoms that may be arranged in random order or in a regular arrangement. Amorphous materials have atoms in random order, while crystalline materials have long-range order. Many materials are transparent to light, at least for small particles or for thin sections. The properties of these materials can be investigated by the effect that the material has on light passing through it. The 6 asbestos minerals are all crystalline with particular properties that have been identified and catalogued. These 6 minerals are anisotropic. They have a regular array of atoms, but the arrangement is not the same in all directions. Each major direction of the crystal presents a different regularity. Light photons traveling in each of these main directions will encounter different electrical neighborhoods, affecting the path and time of travel. The techniques outlined in this method use the fact that light traveling through fibers or crystals in different directions will behave differently, but predictably. The behavior of the light as it travels through a crystal can be measured and compared with known or determined values to identify the mineral species. Usually, polarized light microscopy (PLM) is performed with strain-free objectives on a brightfield microscope platform. This would limit the resolution of the microscope to about 0.4 m. Because OSHA requires the counting and identification of fibers visible in phase contrast, the phase contrast platform is used to visualize the fibers with the polarizing elements added into the light path. Polarized light methods cannot identify fibers finer than about 1 m in diameter even though they are visible. The finest fibers are usually identified by inference from the presence of larger, identifiable fiber bundles. When fibers are present, but not identifiable by light microscopy, use either SEM or TEM to determine the fiber identity. 1.3. Advantages and disadvantages. The advantages of light microscopy are: A. Basic identification of the materials was first performed by light microscopy and gross analysis. This provides a large base of published information against which to check analysis and analytical technique. B. The analysis is specific to fibers. The minerals present can exist in asbestiform, fibrous, prismatic, or massive varieties all at the same time. Therefore, bulk methods of analysis such as X-ray diffraction, IR analysis, DTA, etc., are inappropriate where the material is not known to be fibrous. C. The analysis is quick, requires little preparation time, and can be performed on-site if a suitably equipped microscope is available. The disadvantages are: A. Even using phase-polar illumination, not all the fibers present may be seen. This is a problem for very low asbestos concentrations where agglomerations or large bundles of fibers may not be present to allow identification by inference. B. The method requires a great degree of sophistication on the part of the microscopist. An analyst is only as useful as his mental catalog of images. Therefore, a microscopist's accuracy is enhanced by experience. The mineralogical training of the analyst is very important. It is the basis on which subjective decisions are made. C.
The method uses only a tiny amount of material for analysis. This may lead to sampling bias and false results, high or low. This is especially true if the sample is severely inhomogeneous. D. Fibers may be bound in a matrix and not distinguishable as fibers, so identification cannot be made. 1.4. Method performance. 1.4.1. This method can be used for determination of asbestos content from 0 to 100% asbestos. The detection limit has not been adequately determined, although for selected samples, the limit is very low, depending on the number of particles examined. For mostly homogeneous, finely divided samples, with no difficult fibrous interferences, the detection limit is below 1%. For inhomogeneous samples, most samples, the detection limit remains undefined. NIST has conducted proficiency testing of laboratories on a national scale. Although each round is reported statistically with an average, control limits, etc., the results indicate a difficulty in establishing precision, especially in the low concentration range. It is suspected that there is significant bias in the low range, especially near 1%. EPA tried to remedy this by requiring a mandatory point counting scheme for samples less than 10%. The point counting procedure is tedious and may introduce significant biases of its own. It has not been incorporated into this method. 1.4.2. The precision and accuracy of the quantitation tests performed in this method are unknown. Concentrations are easier to determine in commercial products where asbestos was deliberately added because the amount is usually more than a few percent. An analyst's results can be calibrated against the known amounts added by the manufacturer. For geological samples, the degree of homogeneity affects the precision. 1.4.3. The performance of the method is analyst dependent. The analyst must choose carefully and not necessarily randomly the portions for analysis to assure that detection of asbestos occurs when it is present. For this reason, the analyst must have adequate training in sample preparation and experience in the location and identification of asbestos in samples. This is usually accomplished through substantial on-the-job training as well as formal education in mineralogy and microscopy. 1.5. Interferences. Any material which is long, thin, and small enough to be viewed under the microscope can be considered an interference for asbestos. There are literally hundreds of interferences in workplaces. The techniques described in this method are normally sufficient to eliminate the interferences. An analyst's success in eliminating the interferences depends on proper training. Asbestos minerals belong to two mineral families, the serpentines and the amphiboles. In the serpentine family, the only common fibrous mineral is chrysotile. Occasionally, the mineral antigorite occurs in a fibril habit with morphology similar to the amphiboles. Amphibole minerals consist of a score of different minerals of which only 5 are regulated by federal standard: amosite, crocidolite, anthophyllite asbestos, tremolite asbestos, and actinolite asbestos. These are the only amphibole minerals that have been commercially exploited for their fibrous properties. However, the rest can and do occur occasionally in asbestiform habit. In addition to the related mineral interferences, other minerals common in building material may present a problem for some microscopists: gypsum, anhydrite, brucite, quartz fibers, talc fibers or ribbons, wollastonite, perlite, attapulgite, etc. Other fibrous materials commonly present in workplaces are fiberglass, mineral wool, ceramic wool, refractory ceramic fibers, Kevlar, Nomex, synthetic fibers, graphite or carbon fibers, cellulose, paper or wood, fibers, metal fibers, etc. Matrix embedding material can sometimes be a negative interference. The analyst may not be able to easily extract the fibers from the matrix in order to use the method. Where possible, remove the matrix before the analysis, taking careful note of the loss of weight. Some common matrix materials are vinyl, rubber, tar, paint, plant fiber, cement, and epoxy. A further negative interference is that the asbestos fibers themselves may be either too small to be seen in phase contrast microscopy, PCM, or of a very low fibrous quality, having the appearance of plant fibers. The analyst's ability to deal with these materials increases with experience. 1.6. Uses and occupational exposure. Asbestos is ubiquitous in the environment.
More than 40% of the land area of the United States is composed of minerals which may contain asbestos.
Fortunately, the actual formation of great amounts of asbestos is relatively rare.
Nonetheless, there are locations in which environmental exposure can be severe, such as in the Serpentine Hills of California. There are thousands of uses for asbestos in industry and the home. Asbestos abatement workers are the most current segment of the population to have occupational exposure to great amounts of asbestos. If the material is undisturbed, there is no exposure. Exposure occurs when the asbestos-containing material is abraded or otherwise disturbed during maintenance operations or some other activity.
Approximately 95% of the asbestos in place in the United States is chrysotile.
Amosite and crocidolite make up nearly all the difference. Tremolite and anthophyllite make up a very small percentage.
Tremolite is found in extremely small amounts in certain chrysotile deposits.
Actinolite exposure is probably greatest from environmental sources, but has been identified in vermiculite-containing, sprayed-on insulating materials which may have been certified as asbestos-free.
1.7. Physical and chemical properties. The nominal chemical compositions for the asbestos minerals were given in Section 1.
Compared to cleavage fragments of the same minerals, asbestiform fibers possess a high tensile strength along the fiber axis. They are chemically inert, non-combustible, and heat-resistant. Except for chrysotile, they are insoluble in hydrochloric acid, HCl. Chrysotile is slightly soluble in HCl. Asbestos has high electrical resistance and good sound-absorbing characteristics. It can be woven into cables, fabrics or other textiles, or matted into papers, felts, and mats. 1.8. Toxicology. This section is for information only and should not be taken as OSHA policy. Possible physiologic results of respiratory exposure to asbestos are mesothelioma of the pleura or peritoneum, interstitial fibrosis, asbestosis, pneumoconiosis, or respiratory cancer. The possible consequences of asbestos exposure are detailed in the NIOSH criteria document or in the OSHA Asbestos Standards 29 CFR 1910.1001 and 29 CFR 1926.1101 and 29 CFR 1915.1001. 2. Sampling procedure. 2.1. Equipment for sampling. A. Tube or cork borer sampling device. B. Knife. C. 20 ml scintillation vial or similar vial. D. Sealing encapsulant. 2.2. Safety precautions. Asbestos is a known carcinogen. Take care when sampling. While in an asbestos-containing atmosphere, a properly selected and fit-tested respirator should be worn. Take samples in a manner to cause the least amount of dust. Follow these general guidelines. A. Do not make unnecessary dust. B. Take only a small amount, 1 to 2 g. C. Tightly close the sample container. D. Use encapsulant to seal the spot where the sample was taken, if necessary. 2.3. Sampling procedure. Samples of any suspect material should be taken from an inconspicuous place. Where the material is to remain, seal the sampling wound with an encapsulant to eliminate the potential for exposure from the sample site. Microscopy requires only a few milligrams of material. The amount that will fill a 20 ml scintillation vial is more than adequate. Be sure to collect samples from all layers and phases of material. If possible, make separate samples of each different phase of the material. This will aid in determining the actual hazard. Do not use envelopes, plastic, or paper bags of any kind to collect samples. The use of plastic bags presents a contamination hazard to laboratory personnel and to other samples. When these containers are opened, a bellows effect blows fibers out of the container onto everything, including the person opening the container. If a cork borer type sampler is available, push the tube through the material all the way, so that all layers of material are sampled. Some samplers are intended to be disposable. These should be capped and sent to the laboratory. If a non-disposable cork borer is used, empty the contents into a scintillation vial and send to the laboratory. Vigorously and completely clean the cork borer between samples. 2.4. Shipment. Samples packed in glass vials must not touch or they might break in shipment. A. Seal the samples with a sample seal over the end to guard against tampering and to identify the sample. B. Package the bulk samples in separate packages from the air samples. They may cross-contaminate each other and will invalidate the results of the air samples. C. Include identifying paperwork with the samples, but not in contact with the suspected asbestos. D. To maintain sample accountability, ship the samples by certified mail, overnight express, or hand carry them to the laboratory. 3. Analysis. The analysis of asbestos samples can be divided into two major parts: sample preparation and microscopy. Because of the different asbestos uses that may be encountered by the analyst, each sample may need different preparation steps. The choices are outlined below. There are several different tests that are performed to identify the asbestos species and determine the percentage. They will be explained below. 3.1. Safety. A. Do not create unnecessary dust. Handle the samples in HEPA filter-equipped hoods. If samples are received in bags, envelopes, or other inappropriate container, open them only in a hood having a face velocity at or greater than 100 fpm. Transfer a small amount to a scintillation vial and only handle the smaller amount. B. Open samples in a hood, never in the open lab area. C. Index of refraction oils can be toxic. Take care not to get this material on the skin. Wash immediately with soap and water if this happens. D. Samples that have been heated in the muffle furnace or the drying oven may be hot. Handle them with tongs until they are cool enough to handle. E. Some of the solvents used, such as THF, tetrahydrofuran, are toxic and should only be handled in an appropriate fume hood and according to instructions given in the safety data sheet. 3.2. Equipment. A. Phase contrast microscope with 10x, 16x, and 40x objectives, 10x Whitefield eyepieces, G22 Walton Beckett Graticule, Whipple disc, polarizer, analyzer, and first-order red or gypsum plate, 100-watt illuminator, rotating position condenser with oversized phase rings, central stop dispersion objective, Kohler illumination, and a rotating mechanical stage. B. Stereo microscope with reflected light illumination, transmitted light illumination, polarizer, analyzer, and first-order red or gypsum plate, and rotating stage. C. Negative pressure hood for the stereo microscope. D. Muffle furnace capable of 600 degrees Celsius. E. Drying oven capable of 50 to 150 degrees Celsius. F. Aluminum specimen pans. G. Tongs for handling samples in the furnace. H. High dispersion index of refraction oils, special for dispersion staining. N equals 1.550, N equals 1.585, N equals 1.590, N equals 1.605, N equals 1.620, N equals 1.670, N equals 1.680, N equals 1.690. I. A set of index of refraction oils from about N equals 1.350 to N equals 2.000 in N equals 0.005 increments. Standard for Beckline analysis. J. Glass slides with painted or frosted ends 1 by 3 inches 1 mm thick, pre-cleaned. K. Cover slips 22 by 22 mm, number 1/1/2. L. Paper clips or dissection needles. M. Hand grinder. N. Scalpel with both number 10 and number 11 blades. O. 0.1 molar HCl. P. Decalcifying solution, Baxter Scientific Products, ethylene-diamine tetrasic acid, tetrasodium 0.7 G/L, sodium potassium tartrate 8.0 mg per liter, hydrochloric acid 99.2 G/liter, sodium tartrate 0.14 G/liter. Q. Tetrahydrofuran, THF. R. Hot plate capable of 60 degrees Celsius. S. Balance. T. Hacksaw blade. U. Ruby mortar and pestle. 3.3. Sample pre-preparation. Sample preparation begins with pre-preparation, which may include chemical reduction of the matrix, heating the sample to dryness, or heating in the muffle furnace. The end result is a sample which has been reduced to a powder that is sufficiently fine to fit under the cover slip.
Analyze different phases of samples separately, e.g., tile and the tile mastic should be analyzed separately as the mastic may contain asbestos while the tile may not. A. Wet samples. Samples with a high water content will not give the proper dispersion colors and must be dried prior to sample mounting.
Remove the lid of the scintillation vial, place the bottle in the drying oven and heat at 100 degrees Celsius to dryness, usually about 2H. Samples which are not submitted to the lab in glass must be removed and placed in glass vials or aluminum weighing pans before placing them in the drying oven.
B. Samples with organic interference, muffle furnace.
These may include samples with tar as a matrix, vinyl asbestos tile, or any other organic that can be reduced by heating. Remove the sample from the vial and weigh in a balance to determine the weight of the submitted portion. Place the sample in a muffle furnace at 500 degrees Celsius for 1 to 2H or until all obvious organic material has been removed.
Retrieve, cool and weigh again to determine the weight loss on ignition.
This is necessary to determine the asbestos content of the submitted sample, because the analyst will be looking at a reduced sample. Note, heating above 600 degrees Celsius will cause the sample to undergo a structural change which, given sufficient time, will convert the chrysotile to forsterite. Heating even at lower temperatures for 1 to 2H may have a measurable effect on the optical properties of the minerals. If the analyst is unsure of what to expect, a sample of standard asbestos should be heated to the same temperature for the same length of time so that it can be examined for the proper interpretation.
C. Samples with organic interference, THF.
Vinyl asbestos tile is the most common material treated with this solvent, although substances containing tar will sometimes yield to this treatment. Select a portion of the material and then grind it up if possible.
Weigh the sample and place it in a test tube. Add sufficient THF to dissolve the organic matrix. This is usually about 4 to 5 milliliters. Remember, THF is highly flammable.
Filter the remaining material through a tiered silver membrane, dry and weigh to determine how much is left after the solvent extraction. Further process the sample to remove carbonate or mount directly.
D.
Samples with carbonate interference. Carbonate material is often found on fibers and sometimes must be removed in order to perform dispersion microscopy.
Weigh out a portion of the material and place it in a test tube.
Add a sufficient amount of 0.1 mHCl or decalcifying solution in the tube to react all the carbonate as evidenced by gas formation, i.e., when the gas bubbles stop,
add a little more solution. If no more gas forms, the reaction is complete.
Filter the material out through a tiered silver membrane, dry and weigh to determine the weight lost.
3.4. Sample preparation. Samples must be prepared so that accurate determination can be made of the asbestos type and amount present.
The following steps are carried out in the low-flow hood. A low-flow hood has less than 50 ppm flow.
1.
If the sample has large lumps, is hard, or cannot be made to lie under a cover slip, the grain size must be reduced. Place a small amount between two slides and grind the material between them or grind a small amount in a clean mortar and pestle. The choice of whether to use an alumina, ruby, or diamond mortar depends on the hardness of the material.
Impact damage can alter the asbestos mineral if too much mechanical shock occurs.
Freezer mills can completely destroy the observable crystallinity of asbestos and should not be used. For some samples, a portion of material can be shaved off with a scalpel, ground off with a hand grinder or hacksaw blade. The preparation tools should either be disposable or cleaned thoroughly. Use vigorous scrubbing to loosen the fibers during the washing. Rinse the implements with copious amounts of water and air dry in a dust-free environment. 2. If the sample is powder or has been reduced as in 1 above, it is ready to mount. Place a glass slide on a piece of optical tissue and write the identification on the painted or frosted end. Place 2 drops of index of refraction medium N equals 1.550 on the slide. The medium N equals 1.550 is chosen because it is the matching index for chrysotile.
Dip the end of a clean paper clip or dissecting needle into the droplet of refraction medium on the slide to moisten it. Then dip the probe into the powder sample.
Transfer what sticks on the probe to the slide. The material on the end of the probe should have a diameter of about 3 mm for a good mount.
If the material is very fine, less sample may be appropriate.
For non-powder samples such as fiber mats, forceps should be used to transfer a small amount of material to the slide. Stir the material in the medium on the slide, spreading it out and making the preparation as uniform as possible. Place a cover slip on the preparation by gently lowering onto the slide and allowing it to fall trapdoor fashion on the preparation to push out any bubbles. Press gently on the cover slip to even out the distribution of particulate on the slide. If there is insufficient mounting oil on the slide, 1 or 2 drops may be placed near the edge of the cover slip on the slide. Capillary action will draw the necessary amount of liquid into the preparation. Remove excess oil with the point of a laboratory wiper. Treat at least 2 different areas of each phase in this fashion. Choose representative areas of the sample. It may be useful to select particular areas or fibers for analysis. This is useful to identify asbestos in severely inhomogeneous samples. When it is determined that amphiboles may be present, repeat the above process using the appropriate high dispersion oils until an identification is made or all 6 asbestos minerals have been ruled out. Note that percent determination must be done in the index medium 1.550 because amphiboles tend to disappear in their matching mediums. 3.5. Analytical procedure. Note, this method presumes some knowledge of mineralogy and optical petrography. The analysis consists of 3 parts: the determination of whether there is asbestos present, what type is present, and the determination of how much is present. The general flow of the analysis is 1. Gross examination. 2. Examination under polarized light on the stereo microscope. 3. Examination by phase polar illumination on the compound phase microscope. 4. Determination of species by dispersion stain. Examination by Beckline analysis may also be used, however, this is usually more cumbersome for asbestos determination. 5. Difficult samples may need to be analyzed by SEM or TEM, or the results from those techniques combined with light microscopy for a definitive identification. Identification of a particle as asbestos requires that it be asbestiform. Description of particles should follow the suggestion of Campbell. Figure 1. For the purpose of regulation, the mineral must be one of the 6 minerals covered and must be in the asbestos growth habit. Large specimen samples of asbestos generally have the gross appearance of wood. Fibers are easily parted from it. Asbestos fibers are very long compared with their widths. The fibers have a very high tensile strength as demonstrated by bending without breaking. Asbestos fibers exist in bundles that are easily parted, show longitudinal fine structure and may be tufted at the ends showing bundle of sticks morphology. In the microscope some of these properties may not be observable. Amphiboles do not always show striations along their length even when they are asbestos. Neither will they always show tufting. They generally do not show a curved nature except for very long fibers. Asbestos and asbestiform minerals are usually characterized in groups by extremely high aspect ratios, greater than 100:1. While aspect ratio analysis is useful for characterizing populations of fibers, it cannot be used to identify individual fibers of intermediate to short aspect ratio. Observation of many fibers is often necessary to determine whether a sample consists of cleavage fragments or of asbestos fibers. Most cleavage fragments of the asbestos minerals are easily distinguishable from true asbestos fibers. This is because true cleavage fragments usually have larger diameters than 1 m. Internal structure of particles larger than this usually shows them to have no internal fibrillar structure. In addition, cleavage fragments of the monoclinic amphiboles show inclined extinction under crossed polars with no compensator. Asbestos fibers usually show extinction at 0 degrees or ambiguous extinction if any at all. Morphologically, the larger cleavage fragments are obvious by their blunt or stepped ends showing prismatic habit. Also, they tend to be acicular rather than filiform. Where the particles are less than 1 m in diameter and have an aspect ratio greater than or equal to 3:1, it is recommended that the sample be analyzed by SEM or TEM if there is any question whether the fibers are cleavage fragments or asbestiform particles. Care must be taken when analyzing by electron microscopy because the interferences are different from those in light microscopy and may structurally be very similar to asbestos.
The classic interference is between anthophyllite and biopyrrole or intermediate fiber.
Use the same morphological clues for electron microscopy as are used for light microscopy, e.g. fibril splitting, internal longitudinal striation, fraying, curvature, etc.
1. Gross examination. Examine the sample, preferably in the glass vial. Determine the presence of any obvious fibrous component.
Estimate a percentage based on previous experience and current observation.
Determine whether any pre-preparation is necessary.
Determine the number of phases present. This step may be carried out or augmented by observation at 6 to 40 times under a stereo microscope. 2. After performing any necessary pre-preparation, prepare slides of each phase as described above. 2 preparations of the same phase in the same index medium can be made side by side on the same glass for convenience. Examine with the polarizing stereo microscope. Estimate the percentage of asbestos based on the amount of birefringent fiber present. 3. Examine the slides on the phase-polar microscopes at magnifications of 160 and 400 times. Note the morphology of the fibers. Long, thin, very straight fibers with little curvature are indicative of fibers from the amphibole family. Curved, wavy fibers are usually indicative of chrysotile. Estimate the percentage of asbestos on the phase-polar microscope under conditions of crossed polars and a gypsum plate. Fibers smaller than 1.0 m in thickness must be identified by inference to the presence of larger, identifiable fibers in morphology.
If no larger fibers are visible, electron microscopy should be performed.
At this point, only a tentative identification can be made.
Full identification must be made with dispersion microscopy. Details of the tests are included in the appendices. 4. Once fibers have been determined to be present, they must be identified. Adjust the microscope for dispersion mode and observe the fibers. The microscope has a rotating stage, one polarizing element, and a system for generating darkfield dispersion microscopy. See section 4.6 of this appendix. Align a fiber with its length parallel to the polarizer and note the color of the Beck lines. Rotate the stage to bring the fiber length perpendicular to the polarizer and note the color. Repeat this process for every fiber or fiber bundle examined. The colors must be consistent with the colors generated by standard asbestos reference materials for a positive identification. In N equals 1.550, amphiboles will generally show a yellow to straw yellow color indicating that the fiber indices of refraction are higher than the liquid. If long, thin fibers are noted and the colors are yellow, prepare further slides as above in the suggested matching liquids listed below. Type of asbestos. Index of refraction. Chrysotile. Index of refraction is N equals 1.550. Amosite. Index of refraction is N equals 1.670 or 1.680. Crocidolite. Index of refraction is N equals 1.690. Anthophyllite. Index of refraction is N equals 1.605 and 1.620. Tremolite. Index of refraction is N equals 1.605 and 1.620. Actinolite. Index of refraction is N equals 1.620. Where more than one liquid is suggested, the first is preferred. However, in some cases this liquid will not give good dispersion color. Take care to avoid interferences in the other liquid, e.g. wollastonite in N equals 1.620 will give the same colors as tremolite. In N equals 1.605 wollastonite will appear yellow in all directions. Wollastonite may be determined under crossed polars as it will change from blue to yellow as it is rotated along its fiber axis by tapping on the cover slip. Asbestos minerals will not change in this way. Determination of the angle of extinction may, when present, aid in the determination of anthophyllite from tremolite. True asbestos fibers usually have 0 degrees extinction or ambiguous extinction, while cleavage fragments have more definite extinction. Continue analysis until both preparations have been examined and all present species of asbestos are identified. If there are no fibers present, or there is less than 0.1% present,
end the analysis with the minimum number of slides, 2. 5. Some fibers have a coating on them which makes dispersion microscopy very difficult or impossible. Backline analysis or electron microscopy may be performed in those cases. Determine the percentage by light microscopy. TEM analysis tends to overestimate the actual percentage present. 6. Percentage determination is an estimate of occluded area, tempered by gross observation. Gross observation information is used to make sure that the high magnification microscopy does not greatly over or underestimate the amount of fiber present. This part of the analysis requires a great deal of experience. Satisfactory models for asbestos content analysis have not yet been developed, although some models based on metallurgical grain size determination have found some utility. Estimation is more easily handled in situations where the grain size is visible at about 160 times or about the same and the sample is relatively homogeneous. View all of the area under the cover slip to make the percentage determination. View the fields while moving the stage, paying attention to the clumps of material. These are not usually the best areas to perform dispersion microscopy because of the interference from other materials. But they are the areas most likely to represent the accurate percentage in the sample. Small amounts of asbestos require slower scanning and more frequent analysis of individual fields. Report the area occluded by asbestos as the concentration. This estimate does not generally take into consideration the difference in density of the different species present in the sample. For most samples, this is adequate. Simulation studies with similar materials must be carried out to apply microvisual estimation for that purpose and is beyond the scope of this procedure. 7. Where successive concentrations have been made by chemical or physical means, the amount reported is the percentage of the material in the as submitted or original state. The percentage determined by microscopy is multiplied by the fractions remaining after pre-preparation steps to give the percentage in the original sample. For example, Step 1. 60% remains after heating at 550 degrees Celsius for 1H. Step 2. 30% of the residue of Step 1 remains after dissolution of carbonate in 0.1 mHCl. Step 3. Microvisual estimation determines that 5% of the sample is chrysotile asbestos. The reported result is R equals microvisual result in percent times fraction remaining after step 2 times fraction remaining of original sample after step 1, R equals 5 times 0.30 times 0.60 equals 0.9%. 8. Report the percent and type of asbestos present. For samples where asbestos was identified, but is less than 1%, report asbestos present, less than 1%. There must have been at least 2 observed fibers or fiber bundles in the 2 preparations to be reported as present. For samples where asbestos was not seen, report as none detected. Auxiliary information. Because of the subjective nature of asbestos analysis, certain concepts and procedures need to be discussed in more depth. This information will help the analyst understand why some of the procedures are carried out the way they are. 4.1. Light. Light is electromagnetic energy. It travels from its source in packets called quanta. It is instructive to consider light as a plane wave. The light has a direction of travel. Perpendicular to this and mutually perpendicular to each other are 2 vector components. One is the magnetic vector and the other is the electric vector. We shall only be concerned with the electric vector. In this description, the interaction of the vector and the mineral will describe all the observable phenomena. From a light source such a microscope illuminator, light travels in all different directions from the filament. In any given direction away from the filament, the electric vector is perpendicular to the direction of travel of a light ray. While perpendicular, its orientation is random about the travel axis. If the electric vectors from all the light rays were lined up by passing the light through a filter that would only let light rays with electric vectors oriented in one direction pass, the light would then be polarized. Polarized light interacts with matter in the direction of the electric vector. This is the polarization direction. Using this property, it is possible to use polarized light to probe different materials and identify them by how they interact with light. The speed of light in a vacuum is a constant at about 2.99 by 108 meters per second. When light travels in different materials such as air, water, minerals, or oil, it does not travel at this speed. It travels slower. This slowing is a function of both the material through which the light is traveling and the wavelength or frequency of the light. In general, the more dense the material, the slower the light travels. Also, generally, the higher the frequency, the slower the light will travel. The ratio of the speed of light in a vacuum to that in a material is called the index of refraction, n. It is usually measured at 589 nanometers, the sodium D line. If white light containing all the visible wavelengths, travels through a material, rays of longer wavelengths will travel faster than those of shorter wavelengths. This separation is called dispersion. Dispersion is used as an identifier of materials as described in section 4.6.
4.2. Material properties. Materials are either amorphous or crystalline.
The difference between these two descriptions depends on the positions of the atoms in them.
The atoms in amorphous materials are randomly arranged with no long-range order. An example of an amorphous material is glass.
The atoms in crystalline materials, on the other hand, are in regular arrays and have long-range order. Most of the atoms can be found in highly predictable locations. Examples of crystalline material are salt, gold, and the asbestos minerals. It is beyond the scope of this method to describe the different types of crystalline materials that can be found, or the full description of the classes into which they can fall. However, some general crystallography is provided below to give a foundation to the procedures described. With the exception of anthophyllite, all the asbestos minerals belong to the monoclinic crystal type. The unit cell is the basic repeating unit of the crystal, and for monoclinic crystals can be described as having three unequal sides, two 90 degrees angles and one angle not equal to 90 degrees. The orthorhombic group, of which anthophyllite is a member, has three unequal sides and three 90 degrees angles. The unequal sides are a consequence of the complexity of fitting the different atoms into the unit cell. Although the atoms are in a regular array, that array is not symmetrical in all directions.
There is long-range order in the three major directions of the crystal. However, the order is different in each of the three directions. This has the effect that the index of refraction is different in each of the three directions.
Using polarized light, we can investigate the index of refraction in each of the directions and identify the mineral or material under investigation. The indices alpha, beta, and gamma are used to identify the lowest, middle, and highest index of refraction respectively. The x direction, associated with alpha, is called the fast axis. Conversely, the z direction is associated with gamma and is the slow direction. Crocidolite has alpha along the fiber length, making it length-fast.
The remainder of the asbestos minerals have the gamma axis along the fiber length.
They are called length-slow.
This orientation to fiber length is used to aid in the identification of asbestos. 4.3.
Polarized light technique.
Polarized light microscopy as described in this section uses the phase-polar microscope described in section 3.2. A phase contrast microscope is fitted with two polarizing elements, one below and one above the sample.
The polarizers have their polarization directions at right angles to each other. Depending on the tests performed, there may be a compensator between these two polarizing elements. A compensator is a piece of mineral with known properties that compensates for some deficiency in the optical train.
Light emergence. G from a polarizing element has its electric vector pointing in the polarization direction of the element.
The light will not be subsequently transmitted through a second element set at a right angle to the first element. Unless the light is altered as it passes from one element to the other, there is no transmission of light.
4.4. Angle of extinction.
Crystals which have different crystal regularity in two or three main directions are said to be anisotropic. They have a different index of refraction in each of the main directions. When such a crystal is inserted between the crossed polars, the field of view is no longer dark but shows the crystal in color. The color depends on the properties of the crystal. The light acts as if it travels through the crystal along the optical axis.
If a crystal optical axis were lined up along one of the polarizing directions, either the polarizer or the analyzer, the light would appear to travel only in that direction, and it would blink out or go dark.
The difference in degrees between the fiber direction and the angle at which it blinks out is called the angle of extinction. When this angle can be measured, it is useful in identifying the mineral.
The procedure for measuring the angle of extinction is to first identify the polarization direction in the microscope.
A commercial alignment slide can be used to establish the polarization directions or use anthophyllite or another suitable mineral. This mineral has a 0-degree angle of extinction and will go dark to extinction as it aligns with the polarization directions. When a fiber of anthophyllite has gone to extinction, align the eyepiece reticle or graticule with the fiber so that there is a visual cue as to the direction of polarization in the field of view. Tape or otherwise secure the eyepiece in this position so it will not shift. After the polarization direction has been identified in the field of view, move the particle of interest to the center of the field of view and align it with the polarization direction. For fibers, align the fiber along this direction. Note the angular reading of the rotating stage. Looking at the particle, rotate the stage until the fiber goes dark or blinks out. Again, note the reading of the stage. The difference in the first reading and the second is an angle of extinction. The angle measured may vary as the orientation of the fiber changes about its long axis. Tables of mineralogical data usually report the maximum angle of extinction. Asbestos-forming minerals, when they exhibit an angle of extinction, usually do show an angle of extinction close to the reported maximum, or as appropriate depending on the substitution chemistry.
4.5. Crossed polars with compensator. When the optical axes of a crystal are not lined up along one of the polarizing directions, either the polarizer or the analyzer, part of the light travels along one axis and part travels along the other visible axis. This is characteristic of birefringent materials. The color depends on the difference of the two visible indices of refraction and the thickness of the crystal. The maximum difference available is the difference between the alpha and the gamma axes. This maximum difference is usually tabulated as the birefringence of the crystal. For this test, align the fiber at 45 degrees to the polarization directions in order to maximize the contribution to each of the optical axes. The colors seen are called retardation colors.
K arise from the recombination of light which has traveled through the two separate directions of the crystal. One of the rays is retarded behind the other since the light in that direction travels slower. On recombination, some of the colors which make up white light are enhanced by constructive interference and some are suppressed by destructive interference. The result is a color dependent on the difference between the indices and the thickness of the crystal. The proper colors, thicknesses, and retardations are shown on a Michel-Levy chart. The three items, retardation, thickness, and birefringence, are related by the following relationship: R equals T, N gamma minus N alpha. R equals retardation, T equals crystal thickness in M, and N alpha, gamma equals indices of refraction. Examination of the equation for asbestos minerals reveals that the visible colors for almost all common asbestos minerals and fiber sizes are shades of gray and black. The eye is relatively poor at discriminating different shades of gray. It is very good at discriminating different colors. In order to compensate for the low retardation, a compensator is added to the light train between the polarization elements. The compensator used for this test is a gypsum plate of known thickness and birefringence. Such a compensator, when oriented at 45 degrees to the polarizer direction, provides a retardation of 530 nanometers of the 530 nanometers wavelength color. This enhances the red color and gives the background a characteristic red to red magenta color. If this full-wave compensator is in place when the asbestos preparation is inserted into the light train, the colors seen on the fibers are quite different. Gypsum, like asbestos, has a fast axis and a slow axis. When a fiber is aligned with its fast axis in the same direction as the fast axis of the gypsum plate, the ray vibrating in the slow direction is retarded by both the asbestos and the gypsum. This results in a higher retardation than would be present for either of the two minerals. The color seen is a second-order blue. When the fiber is rotated 90 degrees using the rotating stage, the slow direction of the fiber is now aligned with the fast direction of the gypsum, and the fast direction of the fiber is aligned with the slow direction of the gypsum. Thus, one ray vibrates faster in the fast direction of the gypsum and slower in the slow direction of the fiber. The other ray will vibrate slower in the slow direction of the gypsum and faster in the fast direction of the fiber. In this case, the effect is subtractive and the color seen is a first-order yellow. As long as the fiber thickness does not add appreciably to the color, the same basic colors will be seen for all asbestos types except chrysotolite. In chrysotolite, the colors will be weaker, maybe in the opposite directions, and will be altered by the blue absorption color natural to chrysotolite. Hundreds of other materials will give the same colors as asbestos, and therefore, this test is not definitive for asbestos. The test is useful in discriminating against fiberglass or other amorphous fibers such as some synthetic fibers. Certain synthetic fibers will show retardation colors different than asbestos. However, there are some forms of polyethylene and aramid which will show morphology and retardation colors similar to asbestos minerals. This test must be supplemented with a positive identification test when birefringent fibers are present which cannot be excluded by morphology. This test is relatively ineffective for use on fibers less than 1 m in diameter. For positive confirmation, TEM or SEM should be used if no larger bundles or fibers are visible. 4.6. Dispersion staining. Dispersion microscopy or dispersion staining is the method of choice for the identification of asbestos in bulk materials. Backline analysis is used by some laboratories and yields the same results as does dispersion staining for asbestos and can be used in lieu of dispersion staining. Dispersion staining is performed on the same platform as the phase polar analysis with the analyzer and compensator removed. One polarizing element remains to define the direction of the light so that the different indices of refraction of the fibers may be separately determined. Dispersion microscopy is a dark field technique when used for asbestos. Particles are imaged with scattered light. Light which is unscattered is blocked from reaching the eye either by the backfield image mask in a Macron objective or a backfield image mask in the phase condenser. The most convenient method is to use the rotating phase condenser to move an oversized phase ring into place. The ideal size for this ring is for the central disc to be just larger than the objective entry aperture as viewed in the back focal plane. The larger the disc, the less scattered light reaches the eye. This will have the effect of diminishing the intensity of dispersion color and will shift the actual color seen. The colors seen vary even on microscopes from the same manufacturer. This is due to the different bands of wavelength exclusion by different mask sizes. The mask may either reside in the condenser or in the objective back focal plane. It is imperative that the analyst determine by experimentation with asbestos standards what the appropriate colors should be for each asbestos type. The colors depend also on the temperature of the preparation and the exact chemistry of the asbestos. Therefore, some slight differences from the standards should be allowed. This is not a serious problem for commercial asbestos uses. This technique is used for identification of the indices of refraction for fibers by recognition of color. There is no direct numerical readout of the index of refraction. Correlation of color to actual index of refraction is possible by referral to published conversion tables. This is not necessary for the analysis of asbestos. Recognition of appropriate colors along with the proper morphology are deemed sufficient to identify the commercial asbestos minerals. Other techniques including SAM, TEM, and XRD may be required to provide additional information in order to identify other types of asbestos. Make a preparation in the suspected matching high dispersion oil, e.g., N equals 1.550 for chrysotile. Perform the preliminary tests to determine whether the fibers are birefringent or not. Take note of the morphological character. Wavy fibers are indicative of chrysotile while long, straight, thin, frayed fibers are indicative of amphibole asbestos. This can aid in the selection of the appropriate matching oil. The microscope is set up and the polarization direction is noted as in section 4.4. Align a fiber with the polarization direction. Note the color. This is the color parallel to the polarizer. Then rotate the fiber, rotating the stage 90 degrees so that the polarization direction is across the fiber. This is the perpendicular position.
Again, note the color. Both colors must be consistent with standard asbestos minerals in the correct direction for a positive identification of asbestos. If only one of the colors is correct while the other is not, the identification is not positive.
If the colors in both directions are bluish-white, the analyst has chosen a matching index oil which is higher than the correct matching oil, e.g.
The analyst has used N equals 1.620 where chrysotile is present. The next lower oil, section 3.5, should be used to prepare another specimen.
If the color in both directions is yellow-white to straw yellow-white, this indicates that the index of the oil is lower than the index of the fiber, e.g. The preparation is in N equals 1.550 while anthophyllite is present. Select the next higher oil, section 3.5, and prepare another slide. Continue in this fashion until a positive identification of all asbestos species present has been made or all possible asbestos species have been ruled out by negative results in this test. Certain plant fibers can have similar dispersion colors as asbestos. Take care to note and evaluate the morphology of the fibers or remove the plant fibers in pre-preparation. Coating material on the fibers such as carbonate or vinyl may destroy the dispersion color.
Usually, there will be some outcropping of fiber which will show the colors sufficient for identification. When this is not the case, treat the sample as described in section 3.3. And then perform dispersion staining.
Some samples will yield to Beckline analysis if they are coated, or electron microscopy can be used for identification.
5. References. 5.1.
Crane, D. Asbestos in Air, OSHA Method ID 160, revised November 1992.
5.2.
Ford, W. E., Dana's Textbook of Mineralogy, 4th ed., John Wiley & Son, New York, 1950, p.
7. 5.3.
Selikoff, I. J. Lee, D. H.K., Asbestos and Disease, Academic Press, New York, 1978, pages
320. 5.4. Women Inspectors of Factories. Annual Report for 1898, H.M. Statistical Office, London, p. 170, 1898. 5.5. Selikoff. I. J. Lee, D. H.K., Asbestos and Disease, Academic Press, New York, 1978, pages 26, 30. 5.6.
Campbell, W. E. J., et al., Selected Silicate Minerals and Their Asbestiform Varieties, United States Department of the Interior, Bureau of Mines, Information Circular 8751, 1977.
5.7.
Asbestos, Code of Federal Regulations, 29 CFR 1910.1001 and 29 CFR 1926.58.
5.8.
National Emission Standards for Hazardous Air Pollutants, Asbestos NESHAP Revision, Federal Register, Volume 55, No.
224, November 20, 1990, p. 48410. 5.9. Ross, M.
The Asbestos Minerals, Definitions, Description, Modes of Formation, Physical and Chemical Properties and Health Risk to the Mining Community, Nation Bureau of Standards Special Publication, Washington, D.C., 1977.
5.10. Lilies are fibrous zeolites and endemic mesothelioma in Cappadocia, Turkey, J. OCC Medicine, 1981, 23, 8, 548, 550. 5.11. Occupational Exposure to Asbestos, 1972, U.S. Department of Health Education and Welfare, Public Health Service, Center for Disease Control, National Institute for Occupational Safety and Health, HSM 72, 10267. 5.12. Campbell, W. E. J., et al., Relationship of Mineral Habit to Size Characteristics for Tremolite Fragments and Fibers, United States Department of the Interior, Bureau of Mines, Information Circular 8367, 1979. 5.13. Mefford, D. E. DCM Laboratory, Denver, Private Communication, July 1987. 5.14. Deere, W. A. Howie, Art A. Zussman, J. Rock Forming Minerals, Longman, Thetford, UK, 1974. 5.15. Kerr, P. F., Optical Mineralogy, 3rd ed. McGraw-Hill, New York, 1959. 5.16. Veblen, D.A.R. ed. Amphiboles and other hydrous pyriboles, Mineralogy, Reviews in Mineralogy, Vol 9A, Michigan, 1982, pp 1-102. 5.17.
Dixon, W. C. Applications of Optical Microscopy in the Analysis of Asbestos and Quartz, ACS Symposium Series, No.
120, Analytical Techniques in Occupational Health Chemistry, 1979. 5.18.
Polarized Light Microscopy, Macron Research Institute, Chicago, 1976.
5.19. Asbestos Identification, Macron Research Institute, G&G Printers, Chicago, 1987. 5.20.
Macron, W. C. Calculation of Refractive Indices from Dispersion Staining Data, The Microscope, No. 37, Chicago, 1989.
5.21. Levity, B. ed. Asbestos and Other Health-Related Silicates, ASTM Technical Publication 834, ASTM, Philadelphia, 1982. 5.22. Steele, E. and Wiley, A. Reardon, P.H. ed. Mineralogical Characteristics of Asbestos, Geology of Asbestos Deposits, pages 93-101, SMEAME, 1981. 5.23.
Zussman, J., The Mineralogy of Asbestos, Asbestos, Properties, Applications and Hazards, pages 45-67. Wiley, 1979.